Okay, thank you all for coming in. I will be starting in about 30 seconds or so, maybe a minute. I'm just waiting for the participant count to stop climbing as everybody gets admitted into the room. Just excuse me while I fiddle with slides a minute. Okay, so just a tiny moment longer and I should be with you to deliver part 2. Okay, excellent. I'm going to move on at this point. So these logistics are the same logistics we had last week. So they will be recorded. We will share videos with everybody who has registered in the next couple of days. Questions are every bit welcome as we go. I've got a couple of text communicators open on the laptop next to me, which the hosts will use to let me know if there are any questions pending. I will solicit questions at the end, of course I will, but you're very welcome to ask questions as we go so that the question can be about whatever I have on the screen at the time. And then finally, there's a link to the slides in the chat for you to click on as you wish at the moment if you want to follow along with the slides as we go. So today's topics are slightly more mixed up than last week. So it gives us lots of different things to talk about, whereas last week we were mostly focusing on that continuous stream from starting to write a patch to getting out of the door. So the first thing we talk about is how to talk with Upstream. And predominantly, the main and most important activity we take part in when we're trying to talk to the Upstream is send emails to one or more mailing lists. Based on the maintainers file in the source tree that lets you find out who you should talk to. Now, intrinsic to mailing lists is it is a multi-way conversation. You are not purely talking to the maintainers. And in fact, if you attempt to purely talk to maintainers and exclude others, unless it's a security matter, the maintainers will probably ask you to talk publicly. So the others on the list will be maintainers, reviewers, other developers who have contributed to the subsystem will likely see your emails. And it has to be mentioned if you're working in high profile areas, things like if you're working in high profile areas, things like tech journalists and others will also be involved in taking part potentially and certainly reading the conversations. The final thing to observe is we talk about maintainers quite a lot. Maintainers have got duties within particular subsystems. They may also simply be interested developers in other subsystems. When they see a problem in the kernel, if it's somebody else's subsystem, they may well write a short patch, send it off. So you will also potentially see maintainers you recognize from one system participating in other parts of kernel development. So in terms of talking to Upstream, it is just email. It is an ordinary social communication system. So if you have a question that you do wish to ask, you can just ask it. You can post as a email question. It will help if you are asking questions with the greatest amount of detail. If you post ambiguous questions, the kernel is a high volume space and they risk getting drowned out and ignored. But if you're explaining roughly what you're trying to solve, you're showing that you have looked at patches or code, particular lines of code that you need some help with, you can push that out. And if you need guidance on what you need to do to converge on something that Upstream is likely to accept, it's perfectly acceptable to discuss that on the mailing lists. It won't always be maintainers. It's a particular area when you ask for questions and guidance where you may not get answers from maintainers, you may well get them for other developers. Those other developers also have experience you can use, and you still have to filter decide whether the advice is truly great or not. But yeah, you can just communicate. It's a communication medium, it's what it's for. My personal favorite habit is to have code that I've got as far as I can. And if there is something that I can't decide what the best design approach is, I frame the question as a request for comment, which is a patch where you're asking for comments on a particular patch. So you may have implemented it one way, become worried it's not the most optimal, and solicit requests for comments saying, is this the best or should I try a different approach? Do bear in mind that a large number of the people that you communicate with on the mailing list are not paid to talk to you. Even people whose job it is to maintain the Linux kernel and who do it with company email addresses and with the company's blessing, probably don't have any accountability to their manager to how effectively they talk to specific individual developers. So in a lot, and many other developers simply are volunteers or are working at a company and maintaining in their off hours. They are mostly not paid to talk to you. So when somebody gives you useful feedback, let them know that you appreciate it. It's good manners. It helps build up your own reputation to be participating effectively in the ecosystem. When somebody gives you useful technical advice, showing that you've recognized it to be useful and that you're grateful is a good social contribution. There is the usual reminder that Upstream do not care about your schedule. So asking how I can get this in before 6.2 is unlikely to get you very far unless it is a critical bug that you are seeking to fix and you are trying to protect people from it. If it's a new feature, there is no real prospect of anybody engaging with you in a discussion about schedule. What that means, the issue with scheduling basically means start work as early as possible. The best way to be on time is to start early. And a final observation that, if you asked or communicated upstream and created a consensus, and then you have to go work on something else, and 6 months later you come back and complete it based on the consensus you achieved 6 months ago, the consensus may not still be there. Times change, people change, views change over time. So do be aware of using an event that happened 6 months ago as a source of authority that this is now the right way to do something. It usually will be. But don't assume that advice is infinitely durable if you have to go away and do something else. So working on mailing lists. Mailing lists are public forums, and that means essentially that almost all the business of the kernel, with the exception of kind of exceptions like security bugs and things like that, all the business of the kernel is done on a public mailing list. And that gives a chance for everybody who is interested, including you, to offer opinions and advice and so on, take part in reviews. It also encourages all participants to act reasonably. The fact that you are working in public and that in most cases it is useful to the participants to build their reputations. There is a strong encouragement to act reasonably and to take part meaningfully on mailing lists. So usually people do post with good and helpful intentions, ideas and comments. This next section is in brackets because I am not the best person to express the difference between many world cultures. This was suggested as useful and something I should put on the slide by somebody who is I think a British person working in Taiwan. And they wanted to make sure it was mentioned to companies that the culture on mailing lists typically is quite westernized, meaning that direct conflicts, direct contradictions, if you have the knowledge that, says somebody has done something wrong, you say that they've done something wrong, you pass on that knowledge. You don't get inhibited in terms of passing that kind of information on. So it is usually polite, but it does depend on your culture as to what you interpret as polite. And even more than standard Western culture, mailing list culture for the kernel is extremely blunt to a level that you probably wouldn't see in most Western social situations anyway. The other aspect of mailing list culture is perhaps more technical, and that is that people who take part in the mailing lists do insist on rules for communicating via email that are not necessarily generally followed in corporate email culture. They are unique to technical communities. And The major ones are that emails should be in plain text. There should be no HTML or markup languages. Your email should be sent in plain text. Most of the mailing lists will in fact reject mails that are written in markup languages. And in fact, if you've got the maintainers on 2 and CC, the only people who will get your HTML email are the maintainers who will almost certainly ignore it. The other behavior that you have to get used to when communicating on mailing lists is to not top post. So top posting is the technique that is very common in corporate email, where you press reply, the entire original reply is at the bottom of the message, and then you, at the top of that, you type in a whole new email. So top posting is discouraged. So too is bottom posting. So bottom posting is very much the opposite of top posting. That basically means you quote the entire email, you scroll down to the bottom, and you reply underneath. That is every bit as bad as top posting. The format used by the kernel community is called inline quoting, where you take a appropriately edited for size section of the previous reply, and by edited for size I mean you trim the top and bottom, not that you reword the text. You trim the top and bottom so that you're replying to a specific point, and then you either amplify it or rebut it or disagree with it. And it's a very effective way to communicate in technical subjects, because it forces you to focus on the areas you disagree. So you can say, I agree with everything except, and then quote the bit where you have a disagreement. That's why we trim the top and bottom material. So the idea is, if you agree with something, you can actually remove it from your reply, because it's the last word. You don't need to say anything else. You can remove the sections you agree with and just reply to the places where you have a disagreement. And while that sounds quite confrontational, it is also very effective at helping people figure out where they disagree, why they disagree, and allows consensus to be built instead. So inline replies is a fundamental part of kernel culture and a number of other technical mail-based technical cultures. And the reason for that inline reply is because it helps you focus on solving particular problems together using the text-based medium that isn't as expressive as speech or face-to-face delivery. So while there's the classic kind of joke with the answer being because it messes up the flow of conversation, and the question being, why is top posting bad? That's too much of a summary. It is important to say inline replies are not just about quibbling about what comes first, the question or the answer. They help you focus on the areas that require discussion and discourage discussion on the areas you agree with. In terms of sending plain text email, it is very worthwhile reading the documentation process email clients description, which is advice on how to set up your emailer. You may also find that there is internal corporate information available to you about how you can set up corporate email systems for plain text. There are likely other Linux developers in your company. They are some of the best people to talk to about how to arrange to send plain text emails through your firewall, for example, without them being rewritten. Ultimately, if you fail to follow these rules, which you can of course test by sending an email to your home address rather than to a mailing list, if you fail to follow these rules, almost all the discussion will be about the fact that you've sent the email in the wrong format, and you will get almost no feedback about your patch. And finally, in terms of mailing list culture, maintainers remain the only path. So there is that cultural habit that if somebody gives you negative feedback, a maintainer is unlikely to apply the patch unless they have already disagreed with it themselves. So whoever has reviewed your code, generally it's a good idea to be thinking about what they say. If you get a particularly hostile non-maintainer review, it might be worth waiting a day to see if a maintainer follows up. But generally speaking, you can treat reviews the same whether it comes from maintainers or not, because maintainers will usually defer to other code review anyway. So that's a brief summary of the actual email aspects of working together on the kernel. We're now going to, as we promised last week, to talk about the different tags available. I think I said in the answer to questions last week that we'd look slightly more at what it formally means when you say signed off by. In other words, what are you signing off? What are you signing off when you put signed off by into the bottom of your patch? This document is what you are signing off. This is called the Developer's Certificate of Origin. The Developer's Certificate of Origin. It comes from the Linux Foundation. And this is what you are asserting to the rest of the kernel community when you mark something signed off by. The way it's structured is you are certifying that either A or B or C is true and that D is true. And the vast majority of the time, you're asserting that A is true and D is true. So what section A says is that you wrote the contribution in whole or in part, and that you have the right to submit it under the open source license indicated. That I have the right is mostly recognizing the work for hire doctrine with respect to copyright. So what that means is that if you are employed and you write patches in company time or on company equipment sometimes, that means that the company is the copyright holder of what you have produced. It is a work for hire. So even though you are the author, you probably don't own the copyright if you are working as an employee. So you are asserting that your company has given you permission to submit the code that you've written under the open source license indicated. And I don't think it's very interesting to think about the legal effects of this certificate of origin. The lawyers for the Linux Foundation do believe that it has a useful legal effect, and they know lots more than me about the law. But what I do know is getting your signed offs wrong, signing something off without having had appropriate permission from the employer to release it. If you are discovered doing that, the reputational damage will be very significant to you personally. So you've been signing off things when you didn't have permission to do so. That is a significant reputational risk. And that alone means that you should be taking the certificate of origin seriously. There are some other options, B and C. So B is saying that you are basing the contribution on a previous work that you have modified in certain ways, and that the previous work was covered by the appropriate open source license, so that you have permission to either license it under its current license or relicense if you're choosing to relicense it. But that you have taken open source code from somewhere, it's license compatible with the rest of the kernel, you can include it. And then the third case is what a lot of maintainers rely on, C. When they take changes from people and submit it to Linus Torvalds, they are usually asserting C, that the contribution was directly provided to you by somebody who had already certified A, B, or C, and you have not modified it. And then when Linus accepts a pull request and adds it to his own kernel, he'll add his own sign-off, which again is based on C, that he is signing off that he has received something from a maintainer who has received it from somebody else, until you get the chain back to the original creation. Section D doesn't have the same level of reputational risk attached to it. It's basically saying that you understand that the record of contributions to the Linux kernel are public and unmodifiable. The nature of Git is that once your email address has been written into the version history, the chain of hashes means it cannot be changed. If it was changed, the version control system would actually break. So we're basically disclaiming certain privacy rights by assigning D. But in terms of reputational risk, it's all hosted, all kind of linked to A, B, and C. So it is a serious matter, adding a signed off by, and you should make sure that you have appropriate permissions from your employer, if you're employed, to do that. So reviewed by. Reviewed by has a similar formal statement that is what you attest when you share a reviewed by tag. It is less formal than a signed off by. It's roughly speaking saying that you have carried out a technical review, that if you had any problems, concerns or questions, that the submitter has provided a satisfactory response, whether that is pushing back and saying that they have been, saying that it's not appropriate feedback, or pushing back and or just coming back with a fixed patch. So that anything you have responded back to the reviewer to the submitter has been addressed, and that you believe it to be a worthwhile modification of the kernel and does not contain issues that should stop it from being included. Fourth is a disclaimer to say that it is a statement of review, but not a warranty. You're not guaranteeing that the function, that the patch works as intended. So that's almost a disclaimer to protect yourself, section 4. And the sections in bold are what you should mostly be thinking of when you add a reviewed by. You're saying, I did review it, all of it, and that it's worth adding to the kernel. It makes the kernel better, which ties back to the job the maintainers have of accepting patches to make the kernel better, and that it doesn't contain issues that would argue against its conclusion. In other words, there is no reason to ignore it because it's free of known issues. So that's what you're formally saying when you send a reviewed by. Reviewed bys are very much worth sending out. If somebody makes a change, particularly to a driver that you have written, then if you read their patch, it looks okay, it is entirely appropriate, provided you've read all the patch, to send a reviewed by to say that you are happy with the change, assuming that you are. There is a slightly less formal patch, act by. So act by does not have a formal description of what it means in those kind of certificates and statement of oversights. Act by is basically a formal record that the person who has supplied the act by has looked at the patch and doesn't object to it. It's most commonly used by maintainers to indicate to other maintainers that they're happy for the code to be added into the kernel. They're happy if it touches their subsystem for the patch to be applied, but they're anticipating that a different maintainer will apply it. So, like I say, it's not a super formal statement, but it's usually used by maintainers to coordinate with each other. There are a wide collection of other tags. These are some of the most important. So CC is a tag that you can put into the version control system to formally record that a particular developer or maintainer was notified about the patch. So this is common if you want to send in large changes that maybe change the ASM generic directory, which impacts a lot of architectures and often leads you to have to send emails to a very wide range of people. By recording in CC, then a maintainer can figure out that somebody has been CC'd, that they haven't responded, and they can treat that as a kind of implicit ACK. So particularly when you're working on lots and lots of files, not all the maintainers will necessarily respond. But if you have no objections and you've CC'd appropriate people, other maintainers will treat their silence a bit like an ACK by and assume that it's permission. The other interesting one, or another interesting one, is code developed by. So code developed by is basically compensating for the fact that Git can only record a single author for any given commit. So if you have jointly worked on a patch, then between you, you have to agree that one of you is going to send it in and be the author. The other one will get a code developed by credit, and they would also be expected to add the signed off by. So to add a tag like signed up to code developed by, you have to have permission from the other party, and they have to agree to sign it off as well. There are a number of other ways you can credit. So reported by is a credit to somebody who submitted a bug report. So if somebody says this driver is broken when this happens, and you go in and fix it, you would be expected to add a reported by to credit the person who took the trouble to write the bug report. Tested by is not actually a credit, so that should be in a different order. Tested by is a statement, a bit like act by and reviewed by, to say that you have done some form of runtime testing on the patch. You should usually say, when you add a tested by comment, you should add a little message saying what it is you've actually tested. So for example, if it's one of your drivers that you have submitted and somebody submits a change, then rather than just send a reviewed by, you can still send the reviewed by. But rather than just a reviewed by, you could say a reviewed by and a tested by, and say I did some boot testing and X to show that you have done a little bit of work to show that the patch is good. Then finally we have suggested by. Suggested by is a credit to a person who has, rather than reported a bug, has suggested how the feature could be implemented. So again, if you've been out on the mailing list before you wrote the code, asked for advice from people and they said you could do it like this. Suggested by is a good way to credit the person who suggested or guided you in here to implement something. And then finally, we have fixes. So fixes is mostly to do with providing information about backporting of patches. So if you provide a contribution that fixes a bug, particularly regression, you should add a fixes tag to say where the bug was added. Now, if the bug has always been present, so it's not a regression, it's been added by a driver, then fixes would be the commit that introduces the driver. So if the driver at the point of introduction to kernel had a bug that you were fixed, you would point fixes at the line, the tool that created the commit that introduced the driver. If it is a regression, you point at the commit that created the regression. And this is used by the long-term stable kernel and stable kernel as well, actually. So all the stable kernel maintenance is driven by fixes. So when Linus applies a patch that has the fixes tag on it, there are lots of scripts that the stable kernel maintainers use to identify the fix, figure out if it needs to be applied to 4.14, 4.19, 5. and so on and so forth. And will attempt an automatic backport if it can. So that's the tags. There is a comment that's come in on the question and answer. Act by is, yes, it's based on the same ACK that you have in TCP. So it's the same ACK that comes with the NAC as we discussed last week, and it does stand for acknowledged by. One of the things that is a common beginner mistake when contributing to mail lists is failing to collect tags. So collecting tags means finding all the tags that have been offered via email in reply to your patch and adding them to the patch description. So where you've put signed off by, somebody else will reply to your email and add a reviewed by. When you resend a patch, whether it's a new version or a resend, the submitter is responsible for collecting the tags. So you, as the patch submitter, when you do a resend, have to go back through the mail history, find out who has offered tags to your patch, and modify the patch description to include the tags. It's part of your responsibility to do a resend or a version 2 of a patch. The final step, obviously, when a maintainer applies the patch, they are responsible for collecting the tags on the last revision. So let's say you get it to version 5 of a patch set and a maintainer applies it. If there are a couple of reviewed bys applied to version 5, it's the maintainer's job to collect the tags. So in other words, when you resend, it's your job. Resend or send a new version, it's your job to collect the patches, collect the tags. When a maintainer applies it, it's their job to collect the tags, and they'll typically use a tool like Patchwork or B4 to collect those tags. So there is some manners and etiquette related to the tags. Firstly, with the exception of things like CC, don't add tags without the permission of the person named. And when we say permission of a person named, that can either be an explicit statement, like if I send a reviewed by colon on my name, that's an explicit permission. Or you could do something directly equivalent to the tag and put it in the public record. So if I reply to your patch by saying, I tested this on a ThinkPad X13S and it worked perfectly, somebody might convert that to a tested by. If you're worried, ask. If somebody says, I've tested this and it looks okay, you can apply and say, would you like me to add a tested by? When you receive tags, do not ignore tags when you resend. It is really quite frustrating for reviewers. If you send a 10-part patch series, somebody has reviewed 7 of those patches and then commented on the other 3, and then you do a resend version 2 without collecting the reviewed bys, there's now 7 unchanged patches that you haven't told me that I've reviewed already. I've deleted the old emails. I don't need to keep them. I've already replied. So yeah, it can be very frustrating if people drop tags. So it's important etiquette to remember to collect the tags, but there is the opposite etiquette as well, which is that if you make a massive invasive change to your patch that substantially changes the way it works, you should not preserve tags when you make such big changes. So making minor changes and reacting to most review feedback is okay. But if you were to drop in a whole new algorithm or change the name of all the functions, or make significant changes, you should not preserve reviewed by tags across that boundary. And potentially, if you make changes that would invalidate previous testing, you should drop the tested bys as well. However, you still need to credit the work that other people have done. So you should say that you've done it in the changelog. This patch is a huge rewrite of this. I've had to drop the reviewed bys from such and such and such and such because I've made too many changes to preserve them. So that's tags. Next, we move on to this concept of thinking like a maintainer. Which is all about the different goals that particularly embedded vendor engineers have compared to upstream maintainers. I mean, everybody involved is usually a programmer, but they do have different motivations. And to really get the best out of upstreaming, it is helpful to understand the motivations of the various parties. So yeah, upstream maintainers do a different job to a vendor engineer. And the reason for that, particularly in embedded space, is vendor engineers often work on product-based kernels and quite often these days use older release versions. Once they have shipped product, they quite often freeze the tree and only ever do bug fix work from that point forwards. That often stops all further development when the company then shifts its focus to the next product. The tide is starting to change on the embedded just freeze it and we'll ignore it for the rest of its service life, because even legislative even legislative changes are forcing longer life on consumer electronics. I think the EU is pushing 6 years for certain types of consumer electronics, and it is not believed to be wise or worthwhile to freeze a kernel for 6 years. The kernel community as a whole is pushing back quite strongly and saying that they don't believe that is going to be effective, which is going to cause large-scale rebases of base kernel versions over time. And there are reasons why the embedded industry works like this. A lot of it can be to do with avoiding regression hunting between old and new kernels. But even the new products that come out quite often are just an update to a more recent obsolete kernel, combined with drivers ported from an older tree. So that's the classic embedded approach. Like I say, the more and more commonly, we're seeing upstream first approaches where people upstream and backport to create product trees, which is much more healthy, and it definitely makes it easier to jump forwards if you've been working like that. The final major difference between vendor engineers and upstream engineers are almost exclusively focused on the Linus Torvalds kernel and Linux Next. The even stable and long-term stable trees are just not in the domain of most maintainers. They only care about the latest kernel. The other thing about kernel developers, more so perhaps than any other type of developer, is they often expect to be working on the kernel for years to come. They are also extremely aware that their employer could change during that time. And so the personal motivation of a significant chunk of kernel developers is to work towards the creation of the best kernel they can. If they have an employer who agrees with that goal, that's great. And in many cases, for many senior kernel developers, if their employer wanted to change their focus, they would start looking for a different job where they could retain the focus they currently have. Now, this works for employers because if you hire a really great kernel developer, knowing them to be a kernel developer, you probably want to work as a kernel developer. So it doesn't change the semantic, but those senior maintainers and senior kernel developers are genuinely working to make the kernel the best they can. They're not interested in making an old fork work on different products. So with a slightly silly turn of phrase, vendor kernel, pictorially represented. Now, the slide, this picture originally used to be a 1975 Oldsmobile, a rather, it was a very American looking car to my European eyes, covered in wood panels. I couldn't continue to compare vendor kernels to 1975 American cars, so I have dropped in a picture of this rather wonderful modern muscle car. And I think many SOC vendor companies do kind of view this as that's what they're building. Some of them are aware they're building less powerful systems for different purposes, but that's often what people think they might be building. This is an alternative graphic of the family of things that the maintainer might be trying to keep in mind whilst they work on the upstream kernel. This is a significant collection of differently sized vehicles. There are very, very big vehicles, there are very small vehicles, there are vehicles that are of similar size to the vendor kernel vehicle. The other characteristic of all these images on the display at the moment is these are all electric vehicles. And I don't mean that to suggest that the upstream kernel is looking for, well, I don't mean to suggest that they are more modern or anything like that. I'm suggesting it's to do with the horizon that the upstream kernel is looking at. It knows that it's in it for the long haul. It's not expecting to ship a product next year and be done. So it's not that the now is more modern or advanced. It's the horizon is further away. However, we can get rid of the silly analogies and go for some concrete statements about code that may be contributed upstream. First one, working is not sufficient. It is not sufficient for code to work for it to be accepted to the kernel. It has to have more about it than simply working. And the reason for that is that upstream maintainers ultimately are thinking on that long horizon. They're aware that if they accept your code, there's a good chance it will be a decade or more in the kernel. I mean, it is only now that there is discussions on ending 486 support in the latest kernels. Think about how long it is since you last saw Intel 486 machine. So it's not just whether it works in your kernel. They require the patches to be based on the latest Linux trees. And they don't just have their own opinions about code quality, they also have a strong demand from code quality from other kernel maintainers. There are expectations of the standards and it's a maintainer's job to uphold them. Finally, if it works for you on your architecture, that's great, but the maintainer is going to be very sensitive to breaking other architectures or drivers or failing in different modes or not compiling if you turn off particular kernel features. So that it works and has, hours and hours or months and years of battle-tested execution time is not sufficient to say something is sufficient quality or sufficiently maintainable to be merged into an upstream kernel. The other one that tends to catch you out, particularly if you've copied an existing driver and used it as a template. Being as good as this other driver over here may not be enough. And that's for very simple reasons. The quality threshold that you will have to meet to have your driver added to the subsystem is going to be that of the very best driver in the subsystem, not the very worst driver. Some of those worst drivers are 15 years old and haven't changed much. And you should not be basing your code on slightly old-looking 15-year-old drivers. You should be looking at the very newest drivers and the most maintained drivers, as we discussed last week. Putting it a different way, you can say that the quality threshold for new drivers does tend to go up over time as the maintainer gains experience, and we get to see better written drivers to use as templates. So, yeah, it's very frustrating if you take an existing driver and then get told that that existing driver isn't good enough. I recommend taking it on the chin, changing your driver, and going and changing the driver that you copied, because that is very good for your reputation to recognize not only that the feedback is good, but that it applies to other parts of the kernel as well. But yeah, overall, the maintainer will look at your code differently. They'll be trying to see how it fits into the subsystem, whether it works and plays nice with the drivers. So if they ask for changes, yeah, like all requests for changes, you have to think about them, and generally speaking, it's easier to accept than to push back if they're going to make your code better. The final one is that works for me is also not enough. And what I mean by this is that you might add a patch that adds some complex driver infrastructure to allocate, deallocate certain driver resources that are necessary to do some work. That allocator may have significant overlap with the problem space of the subsystem itself. And so you might well be asked to generalize this complicated code in your driver so it can be used as utility for other drivers to consume. Or putting it another way, you're being asked to refactor your code to make it easy for your competitors to take advantage of it. And that's okay, because of course your competitors in other areas are being asked to refactor their code to make it easy for you to take advantage of it. And even when that's not the case, those other users will still be looking for bugs in your code, fixing it, adding new features and so on, optimizing it, making it faster. So again, this is something that you are likely to have to accept, and the request to generalize can be quite difficult. It can be a significant demand. In some cases, that request for rewrite might involve you getting involved in writing a whole new subsystem. That's the story we have at the end of today. So it can become a big project. That's an exciting opportunity. It also harms your timescales, of course it does. But ultimately, it does get the kernel into a better and more maintainable position. If maintainers did not do this, you would end up with 5 drivers, all of which works for them, containing different bugs and with none of the common features factored out. And maintainers will, once they recognize that this is happening, will work hard not to accept drivers that make the problem worse. So whether it triggers on the second, the third, the fourth driver, or even the first, depends on whether the maintainer notices it coming. But eventually, you will see a hard wall coming down saying, no, this needs to be generalized or we can't take it. So how do you cope with not enough? I mean, my first recommendation is simply to have a accepting patience to the requests that you get. Generally speaking, they are going to make the solution better. It is worth taking these things. The only other major thing you can do to try and cope with this situation is to start early, to make sure that the work you are doing is sufficiently ahead of the curve, that if there are bumps along the way where you have to do work and rewrites, that it doesn't affect your eventual endpoint. So the last thing before we look into the tools and techniques, which are quite sort of central to today, is to look at the kernel versioning and release flow. So this is the kind of heartbeat of kernel releases. So first off, we have kernel versioning. So the 2-digit versions, so v5.7, is the signature of a Linus Torvalds release. When you have a kernel that has only 2 version numbers, that is the release that has come from Linus Torvalds. Immediately after that version is released, it is declared stable. It becomes the stable kernel. And there is only one stable kernel at a time. The others are long-term support or long-term stable, but there's only one stable kernel, and that's the one that Linus has most recently released. And it will get updates for a short period of time after release. So we're expecting kernel 6.1 to be released shortly. It will become the new stable kernel, and it will get a few patches applied to it as we work through. Stable trees do not accept new features, but they use that fixes tag and a couple of other mechanisms to backport bug fixes to the stable kernels. In addition to the stable kernel, there are also long-term stable kernels, which are a multiple set of kernels which we give, or the kernel community gives support to for a longer period of time. Initially, the time span that a kernel is maintained long-term stable for is 2 years. And it is becoming quite common in recent years for that 2-year period to be extended to 4 years, but there is no expectation of that growing further at the moment. So, for example, version 4.4, which is retired now, is no longer getting long-term support. It had 302 releases in its lifetime. To give you an idea of the churn, that's in a 4-year period, release every kind of, what, 5 days? So 302 releases, all with backported bug fixes from other mainline kernels. No stable kernel, not even the stable kernel, is a acceptable upstream for sending patches. Patches should always be against the latest Linus Torvalds kernel. And then finally, a strategy that's quite common. It's an example that the Qualcomm landing team adopts, among others, is to provide trees for starting products on that are based on long-term stable trees. So the idea is the drivers for the Qualcomm hardware get sent upstream first. Once they're accepted upstream, they are back-ported on top of the long-term stable tree by the Qualcomm landing team, and that becomes their recommended basis for product releases. So that's an upstream first approach to maintaining product trees. If you're interested in how it looks, kernel.org provides you a good summary of all the things that are going on. So you can see here we've got mainline, this is 6.1 RC8. We've got the most recent stable, so there's already been 11 versions of the 6.0 kernel to have bug fixes. And the stable kernel is intended to be the best kernel that the kernel community can offer you. So you'll notice that latest release will give you 6.0.11. That's what the stable kernel is. It is intended to be the best and most featureful and most bug-free version of the kernel that the kernel community can offer you at any one time, is always the stable kernel. The long-term kernels have fewer bug fixes than the stable kernel typically, but of course it does depend which bug fixes you need. These are the currently active long-term stable kernels: 5.15, 5.10, 5.4, 4.19, 4.14 and 4.9. You can see that these bottom two have got huge numbers of patches, and that 4.9 is now many times more patches even than 4.4. I believe 4.9 is going to go out of the support period fairly soon. So that's the kernel versions. Oh, I think I've already explained this, but the fact that when a new long-time kernel is created, it's given a 2-year projected end of life, but that many long-term kernels have an extended life added to them to make it up to 4 years. The result of that quite often is that the most recent long-term stable will appear to have a closer end of life than a later thing. That often causes people to adopt the older release unnecessarily, because they want the one with the longest supported date on it. That's usually a mistake, because quite often the long-term dates will be extended. But in any case, if you are interested in the durability of any particular release at the moment, that's where you can look to find out. So the next thing that us upstreamers we want to understand is the kernel release cycle. So the kernel release cycle applies to new features that you want to land in the kernel. And it is a never-ending cycle. So as soon as you get to the next release, it becomes the previous release, and we continue on. So when Linus makes a release, the very fact that he has made a release opens up the merge window, which is a 2-week period when maintainers can send pull requests to Linus to have him take code into the kernel. The merge window is not a time where maintainers accept contributions from developers. The merge window is when maintainers send their code to Linus. It is not when they accept changes. For the most part, it's actually inverted. So as a contributor, your best kind of window for sharing patches is the early part of the release candidate cycle. So RC1, maybe 2 to RC3 is the best time you have to release code that you want to get, not to the next release, but the release after that. So the idea is that you are submitting code here, you're allowing it to go through review, and hopefully by around kind of RC5, RC6 sort of time, in the ideal world, you'd have acted on the review comments, made the maintainer happy, and the maintainer could apply it in about RC6. Linus would then release the next release, which would open up the merge window. So your feature would be merged into the kernel at this point after the next release. And then there'll be the whole release candidate cycle all over again. So maybe 17 weeks after you initially start sharing your patches, down to 12 weeks or so. That's about the fastest you can get new features into the kernel. You can barely get it, so that's 3 months basically minimum, and going up to more than that if you're not aligned to RC5 and get your code dead right by RC5. So that means you're talking about a minimum of about 3 months to get new features into the kernel, and that's in the best case where your code doesn't attract review comments. So that's important to understand about the merge window. The merge window is for maintainers. Your time to shine comes during the release candidate period. Most maintainers will close their trees at some point. So it's quite common for big trees to close around RC4, RC5 and RC6. And what they're doing basically is they're freezing their work so that they can run a bunch of tests on it and get ready to send a pull request in the merge window. So they're getting it ahead of time, they're merging the patches they want to take around about RC6, they're spending a couple of weeks testing it, and then when Linus opens up the merge window, they're ready to send the pull request to Linus. Now, none of this applies to fixes. This is for new features. Bug fixes are acceptable all the time, and kernel maintainers can hoover them up at any time, and we'll push them to Linus potentially with only a week or maybe less time, depending on the impact of the bug. So the whole release candidate process is there to allow maintainers to collect patches and fix bugs. So anything that is a bug fix or fixes regression or anything like that can be supplied to the kernel in the release, anywhere, merge window, release candidate, right the way up, any time in this interval. But new features, basically, if you can't get agreement from the maintainer to merge in that feature by around about RC6, you will have to wait for the next kernel cycle 10 weeks after that. So I hope that makes sense. What that means is, the summary of the kernel development cycle is it's about 10 weeks long. It does vary slightly depending on holidays and the number of the amount of churn in the later release candidates. So about release candidate 6, 7, Linus will usually make comments about how many changes there are. If it's very quiet, if he's not getting many bug fixes, he'll release early. If it's very, very busy and he's getting lots and lots of bug fixes, he'll add an extra release candidate or two until it quietens down. The merge window itself is typically 2 weeks, but it can close early sometimes. So when can you send code? So fixes you can send to maintainers anytime you like. You can send new code and cleanups and what we might call trivial bug fixes. So for example, if there's a hugely improbable error path, like an allocator failure, during init. So allocator failures at runtime are a problem. Allocator failures during boot are vanishingly rare. So if you have maybe a probe function that doesn't do good cleanup after an enomem, some maintainers won't rush that into the kernel. They'll treat it like a cleanup rather than as a true bug fix. That's a slightly controversial habit. Some maintainers do that. Some maintainers don't like that other maintainers do that. But that is the reality. Some maintainers will pick them up and sit on them for a couple of weeks, get them into the next merge window and so on. So you can send code and cleanup anytime you like, but it does depend on the maintainer's preferences. But typically it is most efficient for the 5 or 6 weeks after the merge window closes. Certainly if you are choosing between, if you're trying to schedule upstream work and other activities, trying to make yourself available for the 5 and 6 weeks after the merge window closes, or maybe 2 weeks, maybe start at the merge window, do the development, get it ready for RC1 and so on. Trying to hit RC1 with new code is a good way to do project planning. And then finally, on top of all that, we have Linux Next. So Linux Next is a giant merge of 250 plus maintainer trees. So I mentioned that at RC6, maintainers tend to gather new code and then freeze their trees for testing. Those trees are typically called subsystem minus next. So KGDB next, backlight next, TTY next. And the Linux Next kernel is a merge of all the maintainer, well, not all, a significant number of the maintainers minus next trees. So it is a good sense of what is coming in the next kernel. About 2/3, I think, of all the patches that land in the merge window will have spent time in the next ready for testing. So if you want to test code to look for regressions in the next kernel to make sure that your silicon still works in future kernels, then testing in next is a good way to catch those bugs before there are ever regressions on your platform. Excellent. So that is kernel versioning and release flow. We're now going to talk about a variety of different tools and techniques. So there is an introductory slide to tools and techniques, and that is that absolutely nothing about tools and techniques is mandatory, except for a couple of comments I'm going to make about coding style. But other than that, maintainers don't care which tools you are using behind the scenes to produce high quality patches. They only care that your patches come out meeting the kernel standards. But I think there are a number of tools and techniques that you can deploy to make it more likely that your patches will meet the community standard, to make it easier for you to produce high quality work, and to give you the confidence that you have produced high quality work, which is kind of key to upstreaming. So I think these tools and techniques, many of them can make you more productive, but they are also to some extent personal. It is up to you to choose which of the advice in this tools and techniques section that you think is going to change the way you work. And equally, it's up to you to decide which ones you think won't suit you because your brain doesn't work like that or whatever else it is, and you would like to concentrate on other areas. So I'm going to expose you to tools. I don't use every single tool that I'm going to talk to you about. I do use most because I like tools. But yeah, it's optional, but there is quite a lot of interesting things in this section. So firstly, train your style. There are lots and lots of different programmers working on the kernel. Many have strong feelings about source code formatting, and ultimately the kernel would become more pragmatic with different kinds of formatting. So firstly, there's a document called coding style. This is probably a documentation process codingstyle.rst. There was a rename of some of the documentation a while back. You should read the coding style document, you should understand it, you should listen to it, you should act on what it says. There is this thing, the pro tip here. You could read the coding style and adopt it as your personal coding style. And that's fine if the only things you write are the kernel and personal projects. If there are other C projects that you contribute to that are not the kernel, you probably can't do that because you've got to conform to the coding style in other places as well. So whether that's a pro tip does depend on what other coding you do. I mean, I admit that my personal coding style is not far off the kernel coding style, to be honest, when I'm starting projects that have no other constraints. But I am a trainer and a support engineer and just generally interested in many, many different things. So I tend to read lots of code in lots of different formats, and I can reproduce most of it if needs be. The basic rules of the kernel, we use hard tabs. Hard tabs are rendered 8 characters wide. I would not recommend you get clever and configure your editors to use hard tabs in 4 space, but render them 4 spaces wide. That might conform to your personal preferences better, but it will cause alignment problems on things like hanging lines and so on that maintainers will pick up on. So I recommend viewing it hard tabs 8 characters wide. 80-ish character lines is not a hard limit. 80 is not a hard limit. Most of the auto formatting tools that are present in the kernel are configured to wrap at about 80. But where things are clearer, if you use 100 character lines, you can use 100 character lines. Clarity trumps choosing line breaks. Almost every modern monitor is widescreen compared to a traditional terminal. So that width is there if you need to use it. But 80-ish lines is a good starting point. Once you're past column 80, you should be thinking about where to break the line, if nothing else. It's mostly KNR style, slightly modified. The slight modified is the fact that KNR isn't truly consistent. One of the examples is presented in a different coding style to the others. And it's not a random choice. It is a good choice for the kernel. It's both very readable, and the tendency to creep away to the right-hand side because of the width of the tabs discourages overly complicated functions. It does encourage good break into compact functions. So it does tend to discourage very, very complex, deeply nested functions. It is vitally important that the patches you share conform to the coding style, because if you don't, all the discussion will be about your poor coding style and not about the patches. And there are very good reasons for this. So those people who have worked on the kernel and nothing but the kernel, in some cases for decades, have absorbed mental tricks based on this coding style. So humans are like to spot patterns. Our brains light up when they see patterns. Coding styles are part of those patterns. So ultimately, people who have spent a decade working with this coding style read that style faster than any other C style. And the phrase that you tend to come out is hurts my eyes or hurts my brain when they see code that doesn't conform. It's not, obviously, that it hurts their eyes. It's that they are having to invest effort to understand the code, cognitive effort, that they do not normally have to spend, which distracts them from being able to perform the normal review. And that is why they will push hard to make sure you follow the correct style. Now, other maintainers do it because other maintainers expect it. Like I say, I'm a jack of all trades. I can read C in lots of different styles, possibly less efficiently than people who work in a single style. But I'm adaptable, and I follow it because I am required to for the sake of other kernel developers. Anyhow, you have scripts checkpatch.perl minus strict, which is an excellent way to start looking for trouble. Strict does give you errors and warnings that are more pedantic than usual, but they're a good way to learn. You know, if you've used checkpatch not just as a tool to check your code for you, but also to help teach you elements of kernel culture in an interactive way, turning strict on makes sense in that context. So learn about the problems and fix it before anybody else discovers you ever made a mistake. You can run checkpatch on something that's not a patch, although it's called checkpatch. You can give it -F and point it to a file that you are currently writing. So if you're writing a new driver, then every so often, in addition to compiling it, you can point checkpatch at it and make sure that the new driver hasn't got lots of coding style errors built in. You should generally fix any errors that are reported by checkpatch, or send a bug report to the authors if you think the error is wrong, because then you can point to that in your description and say, this does have a checkpatch error in it. I've submitted this bug report. Where you see warnings, you should think very carefully about whether you have an excuse for requiring the warning. So if you haven't got a good reason to write the code in that way, try to avoid the warning. If you have got good reasons to write it, the very nature of warnings is that they aren't always correct. They aren't always assigned as a mistake. And in general, adapt your Linux coding style. Every time checkpatch educates you, try to get it right next time automatically, rather than have checkpatch pick you every time, because that hurts your productivity over time. So, training your style. Don't assume nobody cares about white space. They do. They care about it a lot. Maintainers who've been in the business a very long time may simply reject or decline to read a patch that isn't formatted properly. So checkpatch -Perl will cover lots of things well beyond white space. You should always run it. It is the most fundamental static analysis tool that the kernel offers to help you get things right. One counter thing, though, is if you see bad style or inefficient use of white space in the existing kernel, be very cautious about just reformatting. In particular, you mustn't use automatic format tools that change the whole file, because when you submit a patch, you're expected the patch to do just what it says on the tin and nothing else. And fix this bug and change a whole bunch of white space makes kernel developers very, very unhappy, largely because backporting white space changes is just not done, because there's churn on the code, it's the bit that bit rots most easily. It makes the patches unmaintainable. So don't just fix this one additional broken line. If it's not worth sending a patch for on its own, where you can say, I'm fixing this white straight because it's broken. This is why I have a white space change. Generally, leave existing code alone. If the maintainer hasn't felt the need to fix it up, you don't need to fix it up either. Which leads us into a tool. The tool is called Clang Format, and it can make a very significant difference to the way you think about laying out source code. It is introduced in this conference talk by Chandler Carruth of Google, called Making C++ Easier, Faster and Safer, where it introduces Clang Format to the audience. But the very essence of Clang Format, it moves down to mash a button, which is a phrase from Chandler, mash that button, and it doesn't reformat the file. It only reformats the statement or selection that you currently have in your editor. So it's a very fine-grained, fix the indentation of this line. Now that's really great for editing, because you can mash out the code any old how, stab the button, have it be automatically formatted. You can then either accept the automatic formatter, which is excellent in terms of its heuristics. It has a very good chance of doing a better job than you would have done at laying it out. But if you do disagree, you can then fix it up, and because it only affects the statement you're currently on, you can then go on with the rest of your life without having to worry about that change being undone at some point in the future. Somebody's asked whether it is check patch minus strict or check patch minus strict. I could probably go and find out just before we move on to check patch. I need to do this anyway because we're coming into a demo. Sorry, I've mistyped that again. I just felt it under my fingers being wrong. There we go, right. So, sorry, that's the demo from this morning. So, scripts, check patch. It is strict gone. Well, I haven't changed it since I wrote this, have they? Can't see strict anyway now. It is possible that it has been removed, and therefore that's why we can't find it anyway. Oh no, it's subjective. Ah, yeah, that was the thing. It is minus strict, not minus strict. And yes, the essence of it is it could be called pedantic. They've got subjective as another way to look at it. Subjective is a better description than strict. It is enabling tests that people could argue about the efficacy of. Different subsystems might have different views and things like that. So that is what we get from check patch script. Check patch minus strict. Okay, so back to Clang Format. If you receive patches from a colleague that are appallingly laid out and you don't feel you could do anything useful with them until they've been adapted to kernel coding style, you can ask for patches to be changed as a pipe. You can also, just ask Clang Format to reformat a whole file if it's a driver that you've got that has been built by somebody who built it with force-based tabs and it just needs an initial go before you tidy it up yourself. That's quite rare. Ever since 4.17, there has been a Clang Format control file that describes to the kernel how to describes to Clang Format how the kernel lays out the source code. And for older kernels, you can back forward this particular item. So what I'm going to do at this point is a quick kind of live demo of Clang Format. So there's two things I'm going to show. Ignore the red bars in the margin. That's because I haven't set up the compilation database to help me here. So we have a couple of lines on the screen at the moment. So copy from kernel, no fault. And there's this rather peculiar indentation that is neither two tabs, which you might expect, nor is it lined up with the braces. So it's not wrong, but if I had written that, I would consider that poorly structured. And if I just press tab in my editor, this is a VI editor, so it's modal, or I press whatever hotkey I've used for the Clang format adaptation, it will automatically on there. It's literally just moved it up to line to the brace. And I can do that to other things as well. This one isn't able to bring the second argument onto the top line because it would hit the right margin. So it has lined the two up like that. But if I were to change the no fault back to a simple copy to kernel and ask for it to reformat, it will flow around. It makes making changes to code really quick. It's useful when you're writing. It means you can just write it all on one line, bash it out like that, and then press tab to get appropriate line breaks. But it's even better when you are reformatting code and changing it in certain ways, because you can just mash that button and it will fix it for you. Now, let me show you a slightly more advanced capability. So here we are looking at a couple of macros. Oops. Yeah, no, that's fine. We're looking at a couple of macros. So we've got a collection of bit hot flags, and there's this macro KDB debug. And it's not super easy to read. And it is interesting that if I ask this line to reformat, it recognizes that the line will be more readable if it keeps the brackets together, brings it down a line, and lets us see the logic condition as it truly is. Now, this is much easier to read because it's using all those pattern recognition things that I mentioned when we were talking about coding style. You can see that this is now doing a bitwise comparison of KDB flags against this flag shifted a bit. All right, and it's easier to see it like that than it was like this. It's not super hard, but the back thing and the new line and the fact that this isn't lined up, in the canonical way. So if this was going to be lined up as a multi-line, you'd expect that to be lined up there, and it's not. So it makes it harder to read. But where I really want to show value could come through is have a look at this macro for a moment. So this macro has two bugs. The first one is the dangling else problem. So if you were to drop this into certain pieces of existing code, it would not act like a function. It would interfere with else operations, which would bind to it instead of to the upper level. So to fix that, we classically use a trick called do while zero. It's a common C technique to make C safe. So that has exactly the same functional effect in most cases, but it can never steal somebody else's else condition by mistake. However, that's really, really ugly, super hard to read. I can, however, mash a button. Oh, and add the semicolon. I can mash a button, and it has formatted it nicely for me. Just that one thing, it has picked up the braces, it's indented. It has made a really good job of formatting this in a comfortable manner for me to use. That's so quick. It really does allow me to make fixes like that at so little cost. We can have a second problem here now. So the other problem with this macro is that if text contains a comma, you'd get all sorts of crazy parse errors because a comma acts differently inside a function call than inside an expression. In fact, a lot of people don't realize that the comma is an operator in C, but it is. And so it is legitimate to use it inside certain expressions. And again, this has now caused the backslashes to misalign. And I can mash a button and it lines them all up for me. So this can take a huge amount of pointless work out of your hands. By having this mash a button, make it look good, you can effectively free your brain to think about the bugs that you've written instead of the formatting that you need to do. And it gives you a better shot at finding those problems that you need. So I'm going to stop at that point. That's Clang format. Like I say, it has one of its key things is these carefully crafted line break heuristics. It doesn't just solve indentation. Solving indentation is easy. It also figures out the best place to break lines in some tremendously complicated, sophisticated ways. So it can be a big time saver. It's a tool that I use almost all the time whenever I'm C programming these days. C, C++, any language like that, I bring in Clang format to save me the time in terms of having to do any of the layout. And sometimes I'll disagree with Clang format and tidy up by hand, but 99% of the time it does a better job than I have the inclination to do anyway. Second tool that is fundamental to kernel development is Git. I'm sure most people already know Git. Technically speaking, you could do kernel development without Git, but it would be a fairly miserable experience. For kernel work, ultimately, other version control systems just are less productive for you because of all the work that you're going to have to do with things like format patch and send email at the end of the day anyway. So a lot of this is kind of obvious. You're going to have to be familiar with fetch and pull so that you can grab code from the Linux kernel. You're going to have to be familiar with add and commit so that you can make changes to the kernel. We've talked about format patch, send email already, but the other ones can be valuable. So rebase -i. Git rebase -i, the interactive rebase, is for me the fundamental piece of upstreaming. It's what allows you to hone a patch series and get the code split into patches in the best way possible. Git rebase is what makes that possible. I view, once you've written the code, interactive Git rebases are how you hone it to become a patch set rather than a C file. And when you get code reviews, I act on the code review, I commit the code review, I then do a git rebase -i to move that commit to fix whichever file needs to be fixed. It is over and over again, git rebase is my fundamental go-to tool for crafting patch sets. It's important to understand exactly what its capabilities are and how to recover from making mistakes with it, things like that. We talked about format patch and send email. Cherry pick is quite useful. You can use that to work with backports if you're working on older kernels and want to test if what you've done on the mainline actually still works. It's also useful for picking up patches from other trees and moving them around and things like that. Obviously, being able to work with branch and checkout so that you can back up old branches, you can keep temporary branches, you can separate your work effectively. And then finally, git log is not just something you pipe through less and then use search strings. You can actually do search strings built into git log itself. So being capable of doing effective archaeology with git log is also a way to boost your productivity and help you answer questions about why is this line of code in the kernel. Should probably add git blame to that list as well. The other thing you should know about Git is something about merge conflicts. The reason that white space changes are so despised when attached to other types of changes in the kernel is they tend to create merge conflicts, and merge conflicts are tedious. So making small atomic changes to the one thing that fixes a bug is a way to make the change less likely to experience merge conflicts. So you should have some idea of how you might handle merge conflicts. You tend to learn this organically, particularly as you work through things like Git rebase. And by learning what happens in merge conflicts, you get that ability to try and avoid them as much as possible. So nobody requires you to become a Git expert, but being comfortable in some of those intermediate and advanced level tools. Rebase is not tremendously sophisticated, but it is something that is unusual to people who've come from other version control systems. Some people who've come from other version control systems, it is an unusual one. So in that sense, it is something you should be aware of. Make sure your Git skills are well polished enough that you can productively hone a patch set. So we'll move on from those tools and techniques to filtering mailing lists. So the reason we filter mailing lists is ultimately because we have to. We've said that the Linux kernel development happens on mailing lists. That's what we said at the beginning. But there is no way that anybody could read everything posted to the Linux kernel. Sorry, let me try that again. There is no way that anybody could read everything posted to the Linux kernel mailing list. There's too much of it. But there is the opposite. If you don't read any mailing lists, you will never absorb enough of the kernel culture to make effective contributions to the kernel. So it's important you expose yourself to enough to understand how kernel development works. So the approach I tend to recommend is you can subscribe to Linux kernel mailing list, either directly or indirectly with a separate email account. But you should then employ really aggressive filters to cut the volume down to something you can cope with. So some good general habits for filtering mailing lists. First and most fundamentally is you are not trying to filter out the dross, the stuff you're not interested in. There's too much of it, you will never get a good enough list. You probably want to take an allow list approach. So the default is to delete things that come from the mailing list unless they contain something that gives you a reason to keep it. I also personally don't see any value whatsoever in hoarding old messages, because search engines and web tools and web archives are perfectly adequate for anything that you miss. So what should your filters be doing? So one filter you should have should keep an eye on code that you've already written. If you've got some previous upstreaming done, your filters should be looking for people that are changing code that you have written. If you've contributed drivers or contributed changes to drivers, you should add them to your filters so that if somebody wants to make a bug fix to a driver you've written, you can see this come through, you can read it, you can see if you object, and if you don't object, you can send a review by. That's good for your reputation. It's helpful for getting your driver bug fixed. So it's a win-win situation. So yeah, it's worth watching code that you've previously upstreamed. More than that, though, if it's your first contribution to the kernel, you should also have a filter to keep an eye on what you are working on now. So this is kind of the exercise I set you last week to subscribe to a mailing list that is appropriate to your area of interest. You can also do that by subscribing to LKM and adopting filters. So this is looking for review comments on similar drivers will now pass your desk automatically. You've been told you need to work on a PCIe controller, so subscribe to the PCIe mailing list. Start absorbing some of the activity that happens on the PCIe mailing list or filtered into drivers PCI. If you are trying to figure out how to write filters, you can, of course, git log the driver interest or the directory of interest and look for subject lines that come up. You can also filter by file name, because diffs will always contain the names of particular drivers. If you want to just watch patches and how they progress, you can start jumping on keywords. It is better to subject filter, because if you subject filter, you'll get the whole thread. Whereas if you file name filter, you'll only get the initial patch. And you can learn more by watching the exchange of ideas. So I recommend trying to craft subject filters as best as you can. If you're curious, my major subject filters are debug, KDB, KGDB, and backlight, which reflects both my interest in tools and debugging techniques, and also the fact that I'm KGDB maintainer, or a KGDB maintainer. So that's the sort of thing I tend to use. It's very simple. It does overmatch, because every time somebody adds a PR debug line, if they add PR debug and put it in the subject line, I get quite a lot of dull patches about I've added or removed debug information. But in general, that does put interesting things in front of me. The results, however, will still be fairly high volume. It's unavoidable. And this is a very personal observation. It does not apply to everybody, but I do not like filtering email into a separate mailbox, for the simple reason that it tends to acquire 400 unread messages, which you then delete, and it starts acquiring another 400 messages that you're never going to read. I think there's a lot to be said for passing stuff from mailing lists through your normal mailbox. If you are going to pass it through your normal mailbox, you have to figure out how you can maintain your productivity. And the answer that I have for that is that you should colorize or mark email that comes from the list so that it stands out, so that your normal mail looks different to mailing list traffic. And that means if you're doing quick scans, you don't look at the mailing list stuff, your eyes can slide past it. And the colors can also help you be aggressive with the delete button. So once you have colorized mailing list traffic, then if the subject line doesn't look interesting, you know it's not addressed to you because it came from mailing list. So you can delete it immediately. And that's the other thing that helps you cope with that mail volume. But because it's colorized so you can tell that it wasn't addressed to you, you can be quite aggressive with the delete button if the subject line doesn't get you excited to find out what's in the mail. The only caveat with that I will mention is make sure you only tag mailing list traffic. If you and the mailing list are both in to or CC, you must not tag the mailing list, because that is personal to you. Right? That's somebody asking you a question about a driver you've submitted or giving you a code review. So it is quite important to make sure that you only tag mails that arrive from the mailing list. So in particular, you shouldn't set filters that look for the mailing list address being in to and CC. You should look for other headers that indicate it came from the mailing list and only match those. So if you need to see those headers, have a look at the headers in your mail user agent and find the one that says X mailing list forwarded by, etc., etc. So once we've decided to filter mailing lists, there are a number of different ways we can do it. Obviously, we could just program our mailer. If we use exactly one mailer, back when I used to use Thunderbird, for example, I could configure Thunderbird to recolor everything and to set everything up. These days, I adopted a slightly different strategy. I use a special Gmail account. So in other words, I have a private Gmail account that is subscribed to the Linux kernel mailing list and a couple of others. And because you don't have to be a member of most of the Linux mailing lists to post to them, it doesn't matter that daniel.thompson@linaro.org is not subscribed to LKML. Providing the messages from LKML land in daniel.thompson@linaro.org's email box, I can reply and the post will be accepted by the mailing lists. So that's what makes this work. So I have this special Gmail account that can pre-filter the mail. To do that, I registered my work email as a forwarding address, and I wrote filters to target the messages that I'm interested in, and they get forwarded to my work email. Simple as that. And after forwarding, everything else gets filtered out and deleted, so that my special Gmail account doesn't accrue. That filter doesn't always work. It's quite difficult to get that one working. The advantage of this, there's a couple of simple ones. It's super easy to colorize because I can just match for X forwarded for and my own Gmail name. And that will not happen to stuff that was sent to my work email address. So there's no risk whatsoever that I accidentally colorize the wrong emails. This third point actually is a bit irrelevant these days because the online archives are much better than they used to be. So this used to be the case that you could perhaps archive the last 30 days of traffic and Google's search was quite effective. But the tools I'm about to show you with Law and B4 and others are actually so much better now that they're going to give you a better user experience. Which we move on to right now. So another alternative way of thinking about mailing lists is using this public inbox idea. So public inbox is an archives first approach to mailing lists. It's basically something that can subscribe to a mailing list and produce web archives in this public inbox format, which is really comfortable to work with. So we'll have a quick look at that particular link that I had. Is that going to open? Yeah. If I get rid of the raw, we'll see the basic. Sorry, if I get rid of the raw. This is an email that I sent out, sure, a year and a half ago, to make some changes to how KDB presented a few things. I picked it just presumably because I wrote it just as I was writing the other slide. And it's basically coming up and it's showing us all the things. It's showing us the headers, patch name. I go to a thread overview so I can find out who's replied to it and commented it. So this is somebody hopefully sending me a review by, given the patch number. Yep. And more than that, I can also ask for the raw version of the patch, which is a mailbox. I could literally save as, open it in my mail user agent and reply to it, which is what we are suggesting as one way to use public inbox. It's really trivial because it's based on message IDs. It's really trivial to hand roll automation. So this number in the middle, the from the 2021 through to the .org is a message ID. It's a unique identifier that identifies that email. So I can trivially create a URL from the message ID, and I can then grab it and pipe it into GitAM, for example, if I want to apply the patch locally for testing purposes. If I did not originally receive the email and I want to reply to it, I can grab it off the mailing list archive, law.kernel.org, download it as a mailbox, and then I can open it up in a mailer. So Mutt, in this case, is going to open that as a mailbox for me to use. So public inbox is a convenient, HTML user interface that allows us to work with mailing lists very effectively. The canonical instance of public inbox is what's called law.kernel.org. That's where I've picked up patches for almost all the mailing list related web demos that I've shown this week and last. So it's the canonical instance for kernel developers, and it has the web interface and the raw mailbox download may or be all you require if you're an infrequent contributor. If all you need to do is occasionally dig out a message that you didn't receive in your regular mailer, grab the mailbox so that you can reply to it with a tested by or something like that, the web interface is all you need. But there are additional tools that you can layer on top. So Lay is a tool that can synchronize a search string pointed at a public inbox and sync it to a local email folder. So you can use this as an alternative to subscribing to the mailing list in the first place. If you don't like that filtered approach that I described before with the Gmail filter, and your own mail infrastructure doesn't give you rich enough filtering, you can look at Lay. So what Lay can do is you can point at an IMAP server or a local mail directory, give it a search string, so the subject lines that you like, how far back in time you want to go, etc., etc. And you can ask Lay to download just those mails from the public inbox that match your search strings. This is a much more modern tool than the ones I've described before. Lay has been developed as part of a new set of tools to try and streamline mail-based development, as I think as public inbox. So yeah, Lay can be interesting. I'll show you a very brief command of an example of it in use in a moment. There is also a tool called B4, which is, I'm going to say, an advanced and feature-rich alternative to the curl URL approach I showed you a moment ago. The more advanced feature risk aspect is, sorry, the more advanced and feature risk. I've been doing quite a lot of training today, and I appear to have stopped being able to say rich. So an advanced and feature-rich aspect of it is that it can work from the message ID and download an entire patch series. It will also do things like it can automatically search for successor series, and it will also fetch tags for you. So while fetching, it will not just fetch, but it will also adopt all the tags that you require. So you can imagine that when a maintainer uses this, they can use this to collect all the tags and reviewed by things that are present in the history of the patch set. If you are a Star Trek fan, you are exactly right. Law and B4 and Vigor, which is the kernel.org mailing list server, are all obscure Star Trek references that, to be honest, I had never heard of. But yeah, if you want to know why they've got such obscure names, it's because they are the name of androids within the Star Trek universe. Which is a shame, because B4 is a really lousy name. It's super hard to search for. It gets far too many hits, most of which are nothing to do with B4. So the trick is to search for B4 and maybe mail and patch, and that will give you a much better search experience. So if I create a search and look for B4 mail patch, it's a tool to work with mail and patch. So yeah, it's why we search for it. You can have some blog posts about the introduction of it and how it works. You can find the B4, and eventually you will find the GitHub, which in this case is actually dropped off into the next page. That's the author. You can probably find it from this. Hopefully you can find it from the that first one that tells you how to find it and where to get it and so on and so forth. So yeah, the name is not super convenient to Google for because it's not unique enough. But if you add mail and patch, you will be able to find it. And in terms of showing you what it can do, oh, yeah, you start over here. So I'm back on law.kernel.org, and I'm going to look for some mail. I'm going to look for something with backlight and sysfs in mid. Backlight. And that will pull out a couple of patches. I've had some problems copy and paste, so I won't show you this one, but I will jump to this one for which I've got a pre-code downloaded. So this is a very simple patch set. You can see it's in quite a high version number. because it went through quite a lot of cycles. A lot of those patches have already been applied, and this was just the last few pieces of the driver that still need to be merged to bring it up to full feature. So again, we can look at the thread overview. You can see that we've got 3 patches plus some replies. And we can also see, sorry, at the top, that it's got a message ID. It's got that thing, so it's a covering letter, it's got this unique version number, and it comes from Git. And if I pull up the, sorry, I'm just going to remove the one from this morning. If I pull up my previous B4, there, I can ask B4 to fetch that. It has gone off to law.kernel.org. It's grabbed the thread, so it's picked up all the messages from the thread, saved it in cover, and from mut-f, I can open that and I could reply with a code review if I had happened to have lost the email. So I'm not going to open it up and start showing this off because I'll accidentally send an email to Peter about it. But that is what you get. You can fetch them, you can look at them. There is more you can do. So I can do things like AM, apply mailbox. And that will not just download it, but it will give me some lines describing the attestation. So this is now fetched the signed off by, has made sure it's all been signed. It's doing various bits of check, and it then tells me that I can check this out, run this command to create a branch, this command to apply the patch set. And through that process, I have very quickly managed to extract patches from mail and bridge them into my local Git environment. B4 is got man page and all these other bits and pieces. You'll notice that the starting point was maintainer-oriented workflows. So things like AM is useful for testing. So it's not just maintainers. If you see a patch set go past and you want to test that patch set with your hardware, you are a B4 AM and a make away from running that code in your own Git branch. So it is not just for maintainers. It's anybody who wants to work with accepting patches from mail and bridging them to your local Git repository. What interested me when I saw this recently is some of the contributor-oriented components. So these are things to prepare your series for permission, to send it to the mailing list, and to handle trailers, which looks to me like tag collection. And I'm afraid to say these are quite new. You've seen they're marked experimental. So I have not had a chance to investigate exactly what those components do at the moment. But it is interesting to see B4 starting to generate contributor-oriented workflows. It's part of the goal for the work with B4 is to make mail-based development more approachable. So it is interesting to see this stuff develop, and these tools are already very useful for a number of purposes. Just to show you something freaky that you could do with Lay if you really wanted to, we normally suggest we use git send email to share patches. And we also tell you that you need to have a mail user agent configured for plain text email in order to comply to the expectations. One option that's very common is to configure your primary emailer so it's possible to send text-based email. And that's a perfectly reasonable way to work. The other way you could view things is to have a secondary email client. And you don't even have to teach that email client how to read your company mail. You can use Lay to handle it. So this example is using Lay. Oops, I've just clicked on the slide. It's using Lay to fetch messages from mail servers that have been sent to or CC yourself, in this case my name, and are less than a month old. So that will look for anything that was sent to any kernel.org mailing list with me on to or CC and capture it. That then lets me effectively reply to those emails as I see fit. So lay up is basically the sync, and then I can open up in a secondary email client. And the only thing I've had to do with that email client is teach it how to send email using exactly the same configuration that I would have used for git send email in the first place. So It's an aside, it's not a common way to work. I do know a couple of people who are using lay instead of subscribing to mailing lists. And these search strings don't have to be to yourself. They can also look for subject lines. They can look for changing particular files. This can jump on any mailing list that you wish. So this can be a very effective way to watch mailing lists that you're interested in, particularly if you're still deciding what you're interested in, because it's really quick and cheap and easy to change the search strings. Finally, in this kind of subject around, what was this one called? Mailing lists. Yeah, okay. So as an auxiliary thing that you can work alongside mailing lists, IRC, not on Freenode anymore. Sorry, I missed that this morning. That should be or TFC, I think. Most of the Linux kernel related mailing lists moved away from Freenode about a year or so ago. So on these other chat networks, you tend to want to correspond with a fake user called the Advanced List Service, which allows you to look for the name of channels. So the trick you probably want is to look for channels that start with Linux. You could just do Linux star, or you could add a letter directing to the sort of subsystem that you care about. In the case of M, this is probably the MSM family of Qualcomm platforms that I was looking at the time. You could also look for B or whatever letter it is the subsystem you're interested in starts with. If you are playing on IRC, it is perfectly acceptable in almost all of the Linux chat rooms to sit and watch and just soak things in until you feel confident with the culture. One of the most common things that gets said on IRC is don't ask permission to ask a question. It's instant messaging, but it's not real time. People have lunch breaks, people go to sleep. They may not be there to give you permission to answer a question. If you have a question, it's best just to throw the question out once you've had time to soak up the culture and see if people give you some feedback. IRC can be a very good place to follow up on code reviews. Do not solicit code reviews on IRC unless you know the maintainer really well. But if you've had some back and forth with a contributor by email as a code review, and you either don't quite understand what they're getting at, or maybe you've got an idea of how you could do it differently, you could look to see if you could find them on IRC and say, hey, I'm just reading your email about this, and I think this would work better. What do you think? Upstreaming is a social process. This can be a lubricant. Equally, it's perfectly okay to continue having that correspondence on email if that makes you more comfortable. But IRC can be mentioned, and like I said, I have mentioned this as socializing. IRC often is a place where people hang out and meet people and just chat. So it's not as focused as the mailing list. So moving on from filtering mailing lists, what are other tools and techniques we can use to make ourselves more productive? I think source navigation has to count as something you should get skillful at as a skill in order to work effectively in anything as complex as the kernel. It's the only way you can self-educate yourself about how it works. The reason it comes up in the upstreaming environment is maintainers will ask you things like, are you sure this code is safe when this happens? Question mark. That doesn't mean they found a bug. That means they suspect that you might not have thought carefully enough about this piece of code. Are you sure it's safe? Well, the question makes it your job to find out. You can't just say, I don't know. A maintainer will say, well, get back to me when you do know. So in terms of making sure it's safe, you're going to have to look at the source. You're going to have to find out how it interacts, what locks are involved in the subsystem that you're working with. Will it deadlock if this happens? So it's going to be your job to do the code navigation to figure that out. Sometimes you'll be able to take a shortcut, like, well, I tested it with config debug atomic, but a lot of the time you just have to browse the source to figure out the answer. Now, like I say, there are lots and lots of other reasons that being efficient at source navigation makes you a better developer, but that's the time when it really becomes applicable to upstreaming. So you should always have one or maybe more indexing tools integrated into your workflow. Now, some people are already running editors where this is a no-brainer. It's already done by default. There's no work to do. You just use your editor. Other more kind of well, dinosaurs use separate editors and additional tools. And if you're in that category, this is the sort of place you could be looking. So one particular thing is that indexes are actually built into the kernel build system. There are 3 indexes that the kernel build system already intrinsically knows about: ctags, cscope, and GNU Global. And they have an additional property in terms of source navigation, and that is that they only index the architecture that you're currently building for. And this has some good properties and bad properties. By indexing only the architecture you're building for, you don't get, 10s or 20 implementations of the same function if you hit architecture dependent code. When you look at how spin locks are working under the covers or something like that. And that's good, because too many of these low-level functions is just confusing. But it is inconvenient because you can't then check for certain types of portability problem by looking at different implementations of the same API. So these aren't the only way to index. You can just use wildcard indexes and index every single C file. But the defaults will use Arch to restrict what you can see. You're not limited to using just one indexer. You can use the one built into your editor and one of these if one of these helps you see further in particular cases. In particular, things like cscope allow you to look for the calling and called by relationship, which can be quite useful when you are investigating stack traces or the reaction between certain functions. So it doesn't just allow you to look for where the symbol is defined. You can also take a symbol name and says who calls this function, and cscope allows you to see that. So there are other reasons you might look at multiple indexes, which is they actually give you different dimensions to your index. If you don't really know what I'm talking about, that source navigation hasn't been a thing for you up to this point, you've just used a text editor and it's been good enough for you, then a sane default to play with might be make cscope in your normal kernel build environment, followed by running cbrowser. Cbrowser is a TCL TK based tool, which does give you an idea of how old it is. That is quite a comfortable front end to cscope. So in other words, it allows you to do local code browsing based on indexes that you've generated from your local kernel sources, and you can browse it locally. This isn't a recommendation saying use cbrowser because Tickle programs are the best thing in the world. Tickle programs are old and uncomfortable and clunky. But it's a good default if you don't know what I'm talking about and want to get a sense of what you would be able to do with a source navigator program. There's one minor addition, which is that some of the source navigators you use trip up over something, the subtle definition between a structured declaration and a structured definition. And it maps back to this part of the coding style, which says it's a mistake to use type defs for structures and pointers. And part of the reason for that is it's actually very convenient when you have pointers to structures to have the struct keyword here, because there is now no dependency on the header that implements virtual container. Because we already know the size of P, it is going to be the size of a pointer. And until we start compiling the function inside this, we simply don't need a header to contain the type def. So it allows us to decouple headers from each other, which is why the kernel adopts this style. But technically speaking, when this appears in a header file and we parse it in a C file, we are declaring that a virtual container exists. We're not defining it, we're simply declaring that the identifier exists. And then if you say, find the virtual container, some source navs will show you 200 functions that have it in the function prototype, because that's where it got declared. Not all source navs have that problem, but if you are stuck with one that does, you can fall back to grep as an alternative. Git grep, struct virtual container, and look for that hanging brace. Because that conforms to the coding style, this will almost certainly find the single line in the kernel where the structure is defined. Finally, source navigation doesn't limit you to running on your local machine. The web is also an excellent place to look for source navigators. One of the reasons they are particularly good is they let you see a big picture. Whereas instead of looking at your specific one, you can look at mainline sources if you're working on a vendor kernel. You can look at the source at different versions over time. So I use it as a support engineer. If somebody says I've got a problem with a 4.19 kernel, I will go and look at the 4.19 kernel so I can know what's going on in that kernel. Links are also durable, so you can share them with others. If you've got a resource on the web, you can point to it. And they're also, if you're just traveling at a conference with a Chromebook, they can be good for having a quick look at something that interested you in the conference without having to have everything installed on your local laptop. Alexa is a good place to start. You can self-host that internally if you want to host one for your vendor kernels internally. And there's also the canonical instance at alexa.bootlin.com, which is popular and well maintained. So here you can see we've jumped to the latest stable kernel. I can look for KDB debug state, for example, and it will find where it was defined, where it's used, where it's referenced from. This is the same dangling else thing that I was showing you earlier. I can click on identifiers. I can jump to the appropriate identifiers, find out how they're implemented, and generally jump around the sources and eventually select line numbers within the sources. Select line numbers within the sources and share that to somebody who needs to be pointed to a particular bit of information. So the web can be a good technique for self-source navigation as well, but I think they complement each other. Having an exact copy of your local code is quicker and easier to work with than the web stuff. But when you want to jump through either all the architectures at once, because they'll all be involved in the index in this case, or if you want to jump back and forwards in time, adding the web techniques is a good addition to your local source navigation. Okay, so two more kind of tools, techniques, what you're going to look at. One is static checking, and the other is git bisect effectively. So static checking. Ultimately, static checkers are tools that try to find bugs in your code without executing it. That is the static part of static. Dynamic checkers run at runtime and are linked into your code to look for problems. So I mentioned config debug atomic. That's a good example of a dynamic checker. It looks and checks that preconditions are not violated at runtime. Static checkers don't get to execute the code. They kind of inspect it and try to look for certain common bugs in that way. Why do you need to know about static checkers? One, it might make you make fewer mistakes. And if you make fewer mistakes, then your code will get accepted faster by Upstream. The other is direct and pragmatic. Some maintainers will tell you, your patch introduces a sparse warning, fix that. And if you're unlucky, they won't tell you what the sparse warning was. And if they don't, that's because they kind of expect you to run sparse to figure out what's going on. So it's definitely worth knowing how to run the static checkers, simply so that if a maintainer says you've messed something up, you are able to keep up with them. So the general idea behind static checkers are that they're based on this check machinery inside the kernel. So basically, there's a variable called check. The default value for check is sparse. And it is literally called check C flags and the name of the C file that you're working on. And you can trigger it in two ways. You can set C1, which modifies kbuild so that just before it compiles a file, it also calls the checker. The alternative is C equals 2, which checks the entire file base unconditionally, whether or not it needs to recompile them. And obviously C flags in the kernel does contain a whole pile of GCSP specific arguments that the checker wrapper, sparse, needs to know how to ignore. So it needs to know what it needs to look at. So the -i's, which tell it where the include files are necessary so that it can see preprocess. But the -m that tells it that you don't want to enable thumb into working is of no interest whatsoever for a static checker, so that just gets thrown away and ignored. But it knows how to parse the GCC arguments without getting confused. And the results you'll get back from sparse include some of these errors at the bottom. So sparse, if you're interested, stands for semantic parser. And the reason it does that, the reason for that name is that it generates parse tree from the original C and then runs checkers that walk the parse tree looking for trouble. The major checking feature that it brings is the enriched type system. So if you've looked through Linux code before, you might have spotted the user tags on all the user pointers. You might have spotted, if you've looked at things like IO remap, sorry, getting muddled on the name. If you're looking at things like IO remap, you'll spot the return value from IO remap is tagged MMIO. And the reason for that is that both user pointers and MMIO should never be dereferenced in kernel mode. They should always use accessor functions. So user pointers should use copy to user and other similar family functions. MMIO should use readle, writeall. And you can dereference kernel pointers directly. But by tracking the different address spaces from which pointers belong, we can spot bugs where a pointer has effectively traversed from one address space to another. It's started as user pointer and we've accidentally dereferenced it. There are other types of pointers that we can look at with this enriched type system. So per CPU pointers similarly get tagged on creation to say these can't be directly dereferenced. And there's a couple of other things that are not related to the type system, so it can look for getting confused with bitwise types and for things like unbalanced locks and releases. Again, based on annotations in the type system. So the sort of things you can see, we've got the wrong address space going into this function because probably we should have given it user pointer and we accidentally sent in a kernel pointer. That we've cast something and removed the type information that would tell us what type of address it was. That we've allowed an implicit cast to take place on a type that we wouldn't expect to cast, and so on and so forth. So, like I say, the primary feature is it's using those additional tags that are unique to the kernel. User pointer, kernel pointer is not a thing if you're a user space programmer. It takes those things and it uses it to find bugs in your code. Another checker, Smatch, is actually a static checker based on extending the sparse parser code. And it was designed to try and find errors, and it differs from sparse in the fact that it accepts a higher false positive rate. The issue with static checkers is you have to figure out whether they want to be highly aggressive and try and find as many bugs as possible, or if you want to be conservative so that when they report a bug, you can be fairly confident it is actually a bug. So sparse is from the relatively conservative family, and Smatch, based on the same code base, is very aggressive, trying to keep an eye on you at the cost of possibly wasting your time with a number of things that are not actually bugs. At the bottom of the page is a collection of the sort of examples, the sort of things that Smatch might find for you. And that really is all there is to say to it. To run it, we're putting the same C1, we just have to spell check differently. So instead of saying sparse, it now says -p kernel. And other than that, it works identically to sparse. It's the same code base. Coccinelle is a very different beast. So Coccinelle is an engine to process what are called semantic patches. Now, these are a bit like the unified diff patches that we send to the kernel. They certainly look a bit like it, but they work on semantic approximation. So to explain what I mean by this is a semantic patch that looks for a bug. The bug it looks for is null checking an expression and then null checking the expression pointing to field. And the reason that is a bug is because if the pointer is true, this will short circuit and will never look to find out if field is null or not. And if it's non-null, it won't short circuit and it will crash when it tries to follow the null e pointer. So there is no way that code that looks like that is ever correct. It is guaranteed to be a bug. And it's almost always a typo for double or instead, which is the correct way to spell this. This will now only short circuit if the pointer is true, and the short circuit will then, if the pointer is non-null, and then following E into the field becomes safe to do. So it's a correct substitution. It can fix the bug for us. And then the other detail is that E as an expression can be arbitrarily complicated. So it doesn't mean that E is an identifier. It means that E could be any kind of expression that evaluates the same thing each time. Function calls, if they're known to be constant, true pure functions, and so on and so forth. And then there is an identifier called field. So if it matches any of this, it will spot it and it can report a problem. Coccinelle is not just used. I mean, Coccinelle is a significant contributor to refactoring the Linux kernel. When you make complicated changes to APIs, you can quite often write Coccinelle patches to semantically transform all the client sites. Additionally, however, you can use Coccinelle to only spot the negative, to only spot the remove, and use it to spot bugs. So in this case, you could run this particular detector not to fix the bugs, but simply to report the fact that somebody's written one. And that's what CocciCheck does. CocciCheck doesn't work by interfering with check. It is its own fully separable static analyzer. So it doesn't absorb all the GNU GCC arguments. So it's a separate invocation and it's a different type of static checker. There are other checkers available to you. There is something called CPP check, which you'll find in Make Help. CPP check that you can integrate using the check technique, same as Smatch. You can turn up the warning levels. So if you want to adopt a high level of warnings, bearing in mind there is a reason the kernel turns a lot of these warnings off. But if you want to be warned about particular things the compiler could tell you about during development, just to give you a chance to fix them if you need to, then W=1 can be good for giving you a deeper level of warnings. And then Make Help will also list a number of other types of static checks you can run. So stack usage, approximation, guessing, namespace analysis, looking for problems in versions, header files, things like that. And then to tie it all together in a piece of string, we have the static checkers. Sorry, we have, I was reading the first line there. We have a tool called AI. This is growing obsolete. So this tool has been very useful. I still use it, but it hasn't been updated for a very long time. I think because CI is starting to fill the role, ad hoc CI that you can implement yourself, maybe with GitLab or something, is starting to fill the role that I use this for on my own desk. But we'll discuss what it does anyway. So it basically takes in this case, a set of patches, which I've piped into a test patch set, and it compiles them before we apply the patches with all the static checkings that I've request turned on. It then compiles them after the patch is applied, and it only reports changes. So in other words, I can use tests with high levels of false positives that the existing kernel triggers a lot. And I think all of these options have a certain degree of false positives. But then the report I get will only show the new problems that I've introduced by my new set of changes. So as a kernel maintainer, I can test my code to make sure it does not bring any new sparse errors, it does not bring any new CPP check, it does not bring any new Coccinelle errors. So when that maintainer says, you've introduced a sparse warning, please fix it, it won't always be III behind the scenes, but that's the sort of technique they can use to discover that they know it. But III is just a family of shell scripts. It's not particularly unique. It's just the one that I've picked up on. And like I say, I think these days CI robots tend to be starting to fulfill this role for people. So the final thing we're going to move on to in the tools and techniques section is just handling regressions. So the overall philosophy I have to offer you with regressions is to automate everything you can. If you automate everything, when you find that regression, then the automation will help you find when it was introduced. Automating everything can be hard. It can be time consuming. It can require you to persuade your manager to buy you a power delivery unit that can turn the board on and off so you can reset it no matter what state it gets into. You might just have a relay attached to a reset line. It does depend on the sophistication of your board and how easy it is to re-provision it and rerun tests. The reason for this is, I've mentioned before in previous week that maintainers work hard to make sure every commit is compilable, and mostly we succeed. That makes it possible to perform a binary search across the version history looking for the commit that introduced a regression. If you know it worked then and you know it doesn't work now, you can go and find out which patch it was that made it not work. And git bisect is the tool that allows you to automatically search that, and it does contain additional algorithmic tricks to cope with merges and to cope with compilation failures. So it's not a true binary search, because merges aren't binary; they're a complex web. So the impact is actually quite simple to run. You can say git bisect start and give it the broken kernel and the working kernel. And then there are ways to run it manually. I don't think you should ever run a git bisect manually. I recommend having a shell script that can compile the kernel and run the test. And it uses the return value to communicate with bisect to tell it what's going on. So the values are either going to be the kernel compiled and the test passes, the kernel compiled and the test fails, the kernel couldn't compile, so please give me one that's nearby and I'll have another go. And any other value is a catastrophic fail abort the bisection. So if, for example, you fail to reset the target and can't re-provision it, you might choose to abort. Even if it looks difficult for you to write an appropriate compile test and run the compile kernel and run test, I would say you should try anyway. And the reason for that is that manual bisection is error prone. What almost always happens is you end up with a excuse me. Oh, I've lost my prompt. There it is. You end up with a git bisect good in your version history. You also end up with a git bisect bad in your history. And then you can ignore what it's saying, and the answer is you then use the command line history to go and find which one, because you're too lazy to type it out, and then you accidentally slip and pick the wrong one. That's the most fundamental way in which you are going to be error prone, but there are other ways, because it can take a couple of hours if you're doing a complex one, and it's boring, and you're probably reading the web or learning Rust in a side window. And yeah, you're going to make mistakes. So you use the script to make sure you can't make mistakes. If you haven't got the capacity to reset the target, you use a manual technique. So you write a shell script which rings the terminal bell until you press return, and commands you then to reboot your board or press the reset button or do whatever manual intervention you have to do to put it back into a provisioning mode. Then come back and ask it to have another go at reprovisioning. And the reason you do that is it will then not make mistakes. You can sit in your other window learning Rust or whatever else you do for fun. And when the bell goes off, you reset the board and you go back to doing something that is more productive and more interesting and more valuable to your employer. Just to explain a little bit about what's happening behind the scenes, there are techniques you can use to look for bisectability. So, excuse me, I just clicked on my S button. If you are creating long-lived, complicated patch sets, it is worth you performing bisectability yourself, so that, not necessarily so that you can run the git bisect on it, but so you can make sure that your patches are not going to upset maintainers by breaking bisectability. It's also worthwhile running for your own vendor trees when you get the opportunity, so that you are able to bisect and look for your own regressions if you create them. So I use III for this. Again, there are other tools you can use. I've got a colleague who's poking me frequently to ask me to test the one that he's written, and I really wish I'd got around to doing it by now. Basically, by adding bisectability, it applies one patch at a time, and then reports the change log for each patch instead of for the whole patch set. So it does hugely increase the build time, but in exchange for that, we get a much better view of whether the patch set is bisectable, whether it compiles at all stages of the build. So while we were talking about automating everything, just an aside, this is not really to do with upstreaming, but it's your platform. In the early days of the SOC life, nobody is more motivated than somebody trying to sell it to keep it working. So in that sense, starting to develop automatic testing of boot and basic kernel features becomes very valuable. There are lots of different options you can use for this. There's public labs, internal labs. There are different ways to run it: Jenkins, Lava, GitLab CI, kernel CI. There's lots of different ways you can set things up. And I'm afraid it's not really in scope for the presentation, except to observe that it upstreaming is a valuable consumer. If you've got a lab that allows you to run new kernels and test things, it can be a valuable asset for your upstream work. Not only can you use it to test stuff before you send it, but also once you have upstreamed, you can use that automation to keep the upstream kernel in good condition by alerting people when it stops working on your hardware. And although the community will do lots of useful things for you, you know, lots of developers don't have your hardware, especially if it's new. You are the person who is most going to benefit from doing those tests. There are some thoughts at the bottom of what makes good automation. You know, it has to be accessible, meaning that a developer who is capable of fixing it needs to be capable of running it so that they can find out how to do it on a user selectable tree and find out if they fixed a problem. It has to be scriptable so that those developers can do things like a git bisect and run the particular test from the particular suite on a variety of different kernels to find out when it might have regressed. And then finally, obviously understandable. Whatever testing you're doing, the reports need to be rich enough that you can triage from the failure report rather than have to reproduce it separately and go backwards to things. All of that is mostly philosophical. It applies whether or not you are doing upstreaming, but upstreaming is a useful consumer of this kind of automation. So there's several asides in this section about automation. The next thing is don't tolerate excuses. You know, we would automate, but you need a board farm. We would automate, but it's way too much work. We would automate, but I don't have a PDU to turn my board on and off and reset it. CI is not really my thing. Computers are really good at accurately repeating stuff, and humans are really bad at accurately repeating stuff. So looking for things that you can automate rather than making excuses about what you can't automate is a very valuable philosophy to bring with you. Which hits the final kind of even further aside, that goes for lots of personal activities as well. In particular, email-based workflows are efficient in the review process. Doing all those email handling and the inline replies and everything else, it is a very effective review process. It is quite a hill to climb to do the initial contribution. Many parts of submitting patches, which is the checklist of things that you should be doing when you're about to set up a patch lead, about to release a patch set, can be partially or fully automated. So automate them. Write a script that matches your way of working. My particular script that I use over and over again is a script called git release. Git minus release, and there's a little trick in Git, which is that if you call a utility git minus release, then the main Git binary will call that shell script for you. And I use git release as a wrapper for Git format patch. It's not code that I feel the need to share with the world because it's built into my personal engineering logbook. So I have a engineering logbook, which is actually just a markdown wiki. And in it, I have a item for every patch I've worked on, and that contains things like the covering letter and reminds me who I should be sending it to and CC. It contains a subject line for the covering letter and a couple of other bits of information about the patch series, together with the branch in my Linux repository that the work is contained. So when I run git release, it can look up the branch, it can find my engineering logbook, it can look at my engineering logbook, it can fill in the covering letter for me, and everything that I said last week about filling in that covering letter template is automated, so that when I do version 2 and I release, the covering letter is already there, and I can edit it, add a changelog, regenerate it. It's already there. It's a very simple piece of automation, and it is personal. It is connected to my engineering logbook, which is why I don't see the need to share the code. But the concept, the principle, the idea that you can automate the parts of submitting patches that are mundane and hard to get right, that you can set up Git hooks to run script check patch for you so that you don't forget to run check patch. And in my case, actually, check patch is also built into Git release so that I can't release code without having remembered to run it through check patch at the very minimum. All those activities, all that advice about things you have to remember to do are things you can automate. So yeah, don't tolerate excuses about what you can't automate. Look for what you can automate. And that does have genuine applicability to upstream work, because it is the act of upstreaming that if you only do it every couple of weeks, I don't upstream daily. I don't even upstream weekly. I do if I see a problem, send the patch to fix it. So I don't always remember everything that it said in submitting patches, but I've automated a good chunk of it, so I don't need to. Okay, so we're getting close to the end. The next section is the one that a lot of people really worry about. It is also the one that is most difficult to cope with. When you are being ignored, you've got a manager saying, is this going to be hitting the next kernel release? And the best you can offer is, I don't know. When you're ignored, you have no indication about where you are. So there's a number of things that we have to talk about when we're talking about being ignored. But the first thing is what I'm calling the checklist here. It's, have you done everything that you can do to make sure that your patch set can be absorbed by the kernel maintainers? So in other words, can you do your job better? Before you look at why you're being ignored, you reflect on whether you could do your job better. Because if you're doing your job excellently, then a maintainer who's ignoring you is obviously doing something wrong. If you are doing a bad job, a maintainer who is ignoring you is actually doing what maintainers do best, which is prioritize and work on what they think are the priorities. So have you made your patch set easy to absorb? Is it well described? Is the change log in good condition? Did you describe how it was tested and allow confidence to develop on why this code is safe to accept into the kernel? Be reminded that maintainers often have this kind of I'll do it later bucket for patches that look like they're time consuming to review. So the easier your patch set is to absorb, the less likely it is to be ignored. The other big one is, have you put the correct people on 2 and CC? Double check maintainers, double check mailing lists and other people sent to the same 2s and CCs to make sure that you actually sent it to the right maintainers, that you've picked the right piece. And look at other patches in the subsystem that you're working on. What did they put on 2? What did they put on CC? Have you picked the same set of people? When you can find code that has landed in the kernel recently, have a look to see if they sent it to the right people, the same people that you selected. Are you up to speed with what's happening on the mailing list? In particular, we're now not looking for manners and social techniques, we're looking for clues about maintenance. So how long does it usually take for the code to be reviewed? Is the fact that your code hasn't been reviewed unusual? Or is it perfectly normal for that particular subsystem not to get reviews done within a couple of weeks? Is everything else in the kernel subsystem completely quiet, or is there other code review taking part that you are not part of? Can you find your mail on the mailing list archives? It could have been you got absorbed by some kind of anti-spam. So can you find your messages when you look on the mailing list service? The public inbox, is it there? Section 4 is actually essentially restating 1 in a slightly different way. If it's a big patch set, could you split it up into smaller pieces? Could you send them to different maintainers? Is it easy to review again? Obviously, you should be thinking about the merge window when you're being ignored. So when did you post your patches relative to the merge window? There are maintainers that completely stop accepting patch sets from about RC 6 or 7 through to the next kernel release. They will simply ignore things sent in that time. In most cases, they are deferring it and they'll get back to it. Some maintainers even have personal automation, so they've automated everything. Greg Hartman is a really good example. But if you send a patch to him in RC 7 or 8, as far as I'm aware, I haven't asked him, but I believe he types some kind of editor macro and it just says, yes, my tree is no longer accepting patches because of the next merge window. I will not look at your patch, and he'll tell you when we'll look at your patch in the future. And then he generally does. So he's really transparent. You can feel what he's been working on. You know why you have been ignored because he sent you an email saying I'm going to ignore it for 3 weeks. That's good feedback. That means you've got something to tell your manager. That's not really being ignored. And then finally, if you are sending out resends or version 2, version 3, version 4, have you collected all the reviewed buys and act buys? So If you have not collected them all, they are good statements of support. They help maintainers recognize, the statement of support, remember what reviewed by means. It means they've looked at it, they think it's an improvement, and that there's no reason not to add it. All the things that kernel maintainers care about. So yeah, make sure you have collected any tags if there are any. So that's just have you done all that you can? There are then the simple things. So the resend. This is simply sending the same patch set again that you sent before, possibly with the tags collected, and resend in front of the patch. It's the most common approach, and it is the most helpful if the patch set has been genuinely overlooked, because if it's been genuinely overlooked, your mail's probably been deleted, and by sending a resend, you put it back in the maintainer's email box as a convenience for them. So resend is a resend for a reason. It's because you assume that somehow the previous version got lost. Whether by accident or, I can't work on it, I'm overloaded, I'm going to delete it, who knows, but you're assuming that it got lost. The gentle ping is becoming increasingly common. Maintainer reactions to a gentle ping vary considerably. Most don't mind. I'm certainly not particularly against them, but you will see some jumpy answers from time to time. I have an example here. So gentle ping on this patch series. It's been 3 weeks and nobody's replied to me. Please take note and look at the kernel release cycle. You sent them at RC7. The kernel was closed. So why did you expect me to review it in those 3 weeks? Also, don't send a gentle ping. I don't like gentle pings. If you really think I have lost or forgotten your patch, then send a resend and explain why. So that particular maintainer, Lee, definitely prefers resends to gentle pings. So you can look on mail lists to find out how people react to them. They are quite common and people know what they mean. Which gets to the final kind of concept with maintainers. Kernel maintainers are not all the same. Maintainers will have subtly different likes and dislikes. And to be effective in the area of the kernel you're working on, it can be useful to know the working practice of the maintainers. So all the training that we've been talking about these last 2 weeks covers ideas that are useful. They are the common form. They're roughly a description of how Greg works. And the reason they're a description of how Greg works is because Greg puts in a lot of advocacy to create a fairly common pattern. But yeah, not all the same. So do remember that maintainers are the only path, and that your schedule doesn't. Sorry, let's try this again. So before I talk to some of the more aggressive techniques, be reminded that maintainers are still the only path. Your schedule is not important to them, and you don't want to be poking them in a manner that makes them cross. So you do have to be careful when your goal is to get the attention of a maintainer. If you're being ignored, first thing you have to be sure that you're not just being impatient. And as I alluded to in the checklist at the beginning, look to see if your communication can be improved. And then look at things like the kernel release cycle and any other information that is out there in the public domain as a reason for which they might be busy. And at the point you're thinking, I really am being ignored, I'm getting worried, this is a really good time before you start needling people in mailing lists to stop and to think and perhaps ask for advice from somebody you trust. Whether that's a manager, experienced colleague, mentor, you could contact support@lenara.org, LDTS. But yeah, you have all these kind of collection of options available to you, and it is a very good time to ask for help. So I've mentioned 2 and CC in the checklist, it's item 2. If you're trying to get attention, make sure that you have actually put the people you want to get attention from in the 2. Simple as that. Some maintainers do filter email with extreme prejudice, and that will include ignoring things on which they're CC'd, or deprioritizing things on which they are CC'd. So getting it right, making sure that the person you want action from is into, will make your patch more obvious. Maintainers are often overworked, so critical message should be in the first paragraph of the email. That is why the patch set is important. That's what this patch does. The first paragraph is always the most important. And that patch bombs, meaning very large or very fast updating patch series, do get ignored by maintainers. Well, left for another day. I've used ignored a lot. What it really means is deprioritized, and I'll do it later, and I'll do it later, and I'll do it later. Finally, be aware, of course, that maintainers leave space for others to review patches. So some might ignore RFCs entirely to maintain their workload. In other words, they're relying on developers and reviewers in the same subsystem to contribute to the RFCs. It's not that they don't think RFCs are valuable, it's they're thinking there are other people who can handle that load for them. Resends are popular because if somebody really has, if you're sending out a resend, one of the things of information that you'll provide to the maintainer, other than the fact that here's a patch again, is that it didn't get negative reviews in the previous cycle. If somebody's sending a resend, that's because they got no response. You should never send a resend if you've had a code review. And then finally, do not rush a resend. A week is an absolute minimum, and I would almost never send a resend in less than 2 weeks. There is a special case that is important in the ARM ecosystem, which is Russell King. So Russell King maintains Arch ARM. Not all of Arch ARM, a lot of it is going for the ARM SOC maintainers these days. But if the person you are required to take action is Russell King, be aware that he runs a bespoke patch tracker at this address. And effectively, the rule of thumb I tend to use when I'm working with patches that I need Russell to take are, which hasn't been for quite some years now, I have to admit, are that instead of resending, if I get to the point where I'm thinking I ought to send a resend, I send it to the patch tracker instead, because that showed that it's had a long enough period of public review before it's ready to reply. So there's instructions on how to work with the patch tracker on the patch tracker. That's where to go and find them. Just to show you kind of a good example, this is follow-up. So this is a hi Daniel. This is not me, it's a different Daniel. So this is a patch that has previously been acked by that maintainer and hasn't been taken by any other maintainer, and it's would you consider applying this patch and its DT bindings for your tree for this particular kernel? Thanks in advance. So there's some subtle information in there, and that's that this patch is standalone. That if you were to take this patch, it wouldn't break other components of the system. And it's basically going to ask to take a patch that has been acked and ask them to take it to their tree to get it ready. That's a good follow-up. It's following up the fact that there has been an act by in the past. You can also use IRC, but with extreme care. I don't think I've ever poked patches on IRC personally, largely because I'm not a huge person hanging out on IRC. There is an example here that I did take from one of the histories. This was on ARM Linux. Hey, do you think you could look at this patch in time for 4.2? Otherwise, let me know and I'll schedule a reminder later. Or if you don't tell me anything, I'll take silence and set the reminder anyway. That's quite gentle. You'll notice that's quite gentle. You'll also have to remember that a dev and a mate probably do chat to each other at other times. So this is not their first engagement. It's not the first time they've spoken to each other, and that is important to be aware of. Finally, after all that, if you have been ignored, if you have upped your game, if you have looked to see if there's any excuse and you are not getting any response whatsoever, there is the maintainer of last resort. You always have to persuade a maintainer to take your code. You don't have to persuade the maintainer of the subsystem, but most maintainers will not accept anything that's outside their subsystem. Andrew Morton is the maintainer of last resort. He does. So normally the maintainer of last resort job is to look after unmaintained code. So patches for unmaintained code are quite often copied to Andrew Morton. And you can see that in the documentation for submitting patches, it does mention this. If the maintainer is absolutely unresponsive, and in that sense we can say ignoring resends or pings for a full kernel cycle or more, if that happens, you could contemplate copying Andrew to patches for maintained code. When you do that, you should include something in the covering letter saying, copying both the maintainer and Andrew and explaining why you have CC'd Andrew, because such and such a version hasn't reacted and it's taken this amount of time. Ensure you've picked up all the tags as usual when you resend, and be sure to describe clearly the state of the reaction. I posted it for view this time, and this time. I have not received any negative feedback for the patch at any point. That is the last resort. Quite often, copying Andrew will cause the maintainer to react. And if the maintainer doesn't react and Andrew doesn't object himself to the changes, he will review them as well. If he doesn't object to the changes, he might well take them. I mean, it is well accepted that Andrew can't know the details, intimate details of each subsystem, but he is a very long-term and skilled kernel developer. So we have reached what is the end of time. I'm afraid I am going to overrun with the case study. The case study isn't going to introduce any new information, but it does give you a kind of interesting history of what can happen in complicated upstreaming environments. So this is what we might call the worst likely case. Most upstreaming is quite quick. You submit a patch, you go through a review cycle 2 or 3 times, maintainer accepts it, you're done and you can move on. This is an example where it takes a much longer period of time. So it's a real example of a long, complicated activity. And the reason it wasn't a simple process is not because the hardware is complicated. The hardware is actually conceptually simple in this case, but it was massively fragmented across the ARM ecosystem. Every single vendor implemented a mailbox differently. So it took over a year, 4 different implementations, 7 vendors involved in the process of landing this change to the kernel. And for that reason, it is a worst case example. This was a long period of time. The SOC frameworks in the kernel have matured a lot in the last 10 years, which means you're far less likely to have to introduce a new subsystem to get work done. But innovation will keep happening, and we hope it does, and it's what makes life exciting. So this is a worst likely case. And if you're interested in a more recent case, have a look at something like the laptop privacy screens. These are little things that allow you to stop LCD screens being observed off axis. And both HP and Lenovo have introduced ones you can turn on and off. So you can turn them off, share your screen with colleagues, or you can turn them on if you're working in a coffee shop and you don't want people off axis to read your screen. And they hit this interesting thing. HP was, as far as I remember, the first to market, but it was Lenovo who first landed in the kernel, and therefore HP's implementation that attracted the delays as they tried to common up the code. However, mailboxes. So the case study here, we are motivated by trying to add support for SOC-specific mailboxes and get them working as a service to other subsystems. Lots and lots of SOCs have some kind of mailbox IP. And there was, at the start of time, there was already a single driver in for a single mailbox. And the problem was the second implementer and third implementer had to generalize to get to a state where additional mailboxes were able to work. And it turned out to be much more work than was anticipated. A mailbox is a very simple peripheral, usually designed to send an interrupt to a heterogeneous CPU. And by heterogeneous, I don't necessarily mean a different architecture, but one that does not occupy the same SMP cluster as the Linux instance. So typically it means co-processors. Whether those are small real-time co-processors or very large complicated DSPs, ultimately they are peripherals to which we assign work by tagging the mailbox one way. The second CPU will go away and work independently until it's solved whatever it's been asked to solve, and then it will send an interrupt back via the mailbox. Implementations do vary quite widely, but ultimately their goal is to wake up the other CPU because there's data ready. So first implementation was written by a driver who had to get their own bit of hardware running. So it was a TI engineer who needed it to work on the OMAP. And it was a very long time ago, and it ended up in Arch ARM. So that's where it was upstreamed. And Arch ARM, since that point, you wouldn't take to see things merged into Arch ARM these days, because these days Arch ARM maintainers, ARM64 maintainers don't accept that kind of code. That traces its roots back to a leaders making comments in 2011 that ARM's organization was inadequate. It led to the formation of device tree and other things. And these days you'd expect to see it in drivers, although you might tend to find the first implementation landing in driver's SOC and it being the second implementator who has to bring it into a subsystem. So these kind of things could still happen. First implementation, TI OMAP. This attracted development attention from another SOC vendor. So in this particular case, Loic at ST. Oh, incidentally, I can use the company names with absolute impunity because all this is in the public record. So I'm not revealing any secrets. This is all stuff that happened in public. And that's why I've been using company logos at this part of the presentation. So Loic from ST observed the OMAP driver and was working with someone at TI to generalize it to allow the driver to become common. As it happened by coincidence, the implementation of the mailbox on the ST and TI parts were not that far apart. They had similar data flows, and that allowed a second implementation to be born with both companies on board. While the second implementation was being discussed, the Fujitsu team, which was a landing team within Linaro, were observing the process because of their upstreaming mission, and observed that the ST and TI APIs were not going to work for the Fujitsu hardware because it had a slightly different data flow. So they jumped into conversation. They pointed out that their hardware was slightly different and it would work better with a more generic API. They didn't have to jump in at that point, but by jumping at that point, they got to influence the kernel. This is something like working in the upstream. They got to influence the direction before it landed. Now, it's not that you can't influence the direction after something has landed, but if you see something moving in a direction that doesn't suit you and you can jump in time to redirect it, that often gives you a better outcome. You get where you need to be more quickly. And this resulted in a kind of friendly takeover in the sense that the Fujitsu team member wrote a new mailbox driver. They incorporated feedback from the authors of the other driver to the extent that the previous authors liked the implementation, which is great because otherwise they would have had to defend theirs and there'd have had to be discussion about which one was adopted. But the new driver was attractive enough to the previous authors that they were very happy to adopt it as their own implementation. So that was a friendly takeover. Now, it happened because of all that public discussion on the mailing list. The reminder that discussion in public does mean, simply refusing a competing implementation because it was not invented here is very risky activity. It's not good for your reputation. So everybody who was involved in these discussions, all the 7 companies I'm going to mention, did a good job of cooperating, working together and getting to the point where we can put something upstream. So that discussion resumed with the Fujitsu team member becoming the primary author, and we then see TI, ST, and Fujitsu work. So the reason this is on our logo is Fujitsu was the sponsoring company, but the actual person implementing, as it happens, worked at Linaro, which is how I managed to pick up this particular story. It wasn't me, incidentally. The wider support is that discussion on the list drew attention to it, and there was positive discussion. That led to 3 more companies adopting the new system. Even before it was upstreamed, there were other upstreamers working to bring in these additional APIs. So we had Intel, Samsung, Broadcom come to join. And the capacity to adopt some of those additional users was only possible because of the flexibility that the Fujitsu extensions had offered. So there's now a growing interest around the third implementation. And at that point, a new implementation was posted to the mailing list. Another generic mailbox implementation. From the point of view of the people involved in that third implementation, it kind of came from nowhere. And there's good reasons for that. Until there is a subsystem, you don't have a mailing list. Until there's a mailing list, finding other people working on the same space can be difficult. I mean, there are certain types of crafted search you could do. But ultimately, the Sony team was unaware of the work by Fujitsu and others. And vice versa. So the new Sony stuff landed on the mailing list. And we call this a crisis, it's perhaps over-dramatized, but Greg KH, he's a very senior and influential kernel maintainer, observed the Sony patches and gave them a degree of support. He was stating that he quite liked their approach. which was difficult because like the developers before, he had not, like the Sony developers, he had not seen the other competing implementations. In that sense, everyone filters LKML as is dictated by their needs and experience, everybody. So nobody knows everything. And ultimately, once the discussions happened and the previous work was mentioned and the fact that the Sony implementation was unaware of some of the previous discussions and hadn't contemplated some of the hardware designs, once he'd observed the alternative implementations, he switched his support to the other implementation, and that built up the momentum. I mean, although we call it a crisis, that's really a very senior maintainer observing that a new subsystem is coming into existence and that there is now 7 companies taking part effectively. Result eventually being that Sony was able to use some of the other implementations, and we get that final implementation eventually landing upstream in 3.18. So you can tell this is quite an old story. So yeah, interest in the patch can be helpful. As you can see, it can also provoke competing solutions, and I think it is very impressive that so many companies could put their ego at the door, put aside their solution, and adopt the best solution that people were discussing. And the nature of the kernel mailing list and the way we do reviews and everything else is good at building that kind of consensus. It is disappointing, incidentally, if it's not your implementation that gets picked, but since most people are working to make the best kernel possible, it's also a good thing that people accept. So that's the summary. Maintainers remain the only path. I mean, eventually a maintainer still has to apply the subsystem patch. It's why Greg is influential here. He is the driver framework maintainer and quite often blesses and introduces new subsystems. So maintainers are the only path. Even when the correct maintainer and the right path are not yet clear, maintainers are still the path that you have to use to land code in the kernel. That gets us to the end for today. I'm going to give one last plug for support at linaro.org. So if you want something from me at any point in the future, whether it's about this upstreaming course or anything else that Linaro is engaged with, that is the place you can get in touch to ask us about things. And other than that, I have the thank yous and the question solicitation. So if you have any questions for things that I have or haven't covered, then please do put it in the chat very, very quickly, because, oh, there we go, excellent. Oh, thank you, even better. So yeah, if you have anything else you would like to add, yeah, please do. But I'm going to start doing the go on any moment. Recordings will hopefully be shared shortly. I think it will be this recording that we share. And yeah, thank you all very, very much for joining me. And I hope to see some or all of you in the future. So I should say it like I mean it, shouldn't I? I do actually want to see many of you in the future. So if I'm bumping into conferences, then yeah, say hello, say you took the training. I will be fascinated to see who I meet. And yeah, thank you all for coming.